success, I started my PhD on the same topic. So here, first I'm going to try to present the project where my PhD is included. After that, I will try to clarify some unknown words such as piezoactuator and power converter. Then I will present my PhD subject, and after I'm going to present the solution that I suggested in this topic. And finally, I'm going to summarize the actual task I'm trying to do and the upcoming task until the end of the PhD. So first, what is Project Picardido? So Project Picardido, P4HIDO, aim to improve the performance of off-road vehicle used in wind central projection. So here we aim to improve the safety of the vehicle by reducing the noises and the mechanical vibration. Also, we aim to improve the controllability of this vehicle. And we are choosing to improve the efficiency in order to lower the power consumption, which would permit us to reduce the CO2 emission. But the first question, how is that possible? So the solution introduced in this project is to replace all the classical hydro valve by a new high-speed hydro valve based on piezo actuators. As you can see, this solution compared to other valves have for same hydraulic losses, we would have a higher hydraulic flux, which would permit to improve the efficiency and lower the power consumption. Also, we would have a lower actuation time, which would make possible to increase the switching frequency of the valve, and also we would improve the shape of the mechanical characteristics such as the torque and speed, especially for this kind of application, because off-road vehicles generally they have high discontinuous speed and torque. So if we could improve the shape of the torque and speed, we could reduce the acoustic noises and the vibration of the vehicle. But in order to do that, we need a specific power converter in order to drive the multiple piezo actuators used in this hydraulic transmission. And this is my main task in the PhD. So before that, I will try to explain some unknown words. For example, a piezo actuator is one kind of material which can work by applying an input voltage in order to create a deformation, a high deformation. So the advantage is that this kind of actuator is driven electrically. Also, compared to other solutions, the power consumption is very low. But the biggest challenges, in order to create a sufficient displacement, we need a higher voltage. In our case, we would need a voltage of 1 kilovolt. This is why we would need a power converter. A power converter, its main task is to convert an electrical energy to another electrical energy by changing the waveforms of the voltage or current, or by increasing or decreasing the voltage or the current. And the power converter is designed specifically to meet the requirement of a specific electrical load. In our case, the electrical load will be the piezo actuators. So as I said before, the main task of my PhD is to design a power converter able to drive multiple piezo actuators with a square wave voltage between 0 and 1 kilovolt. And the time actuation need to be fixed at 1 millisecond. But the supply voltage will be a battery of 48 volts. So we would need for this power converter to have a very high voltage gain to go from 48 to 1 kilovolt. Also, the time actuation need to be fixed at 1 millisecond. And finally, we would like to drive individually each piezo actuator. So the biggest challenge here is to find a dedicated power converter topology. Also, we need to consider some criteria such as the size, the efficiency, and the converter dynamic when we try to control the voltage. And finally, because the piezo actuator has a strong capacitive behavior, we would like to to recover the energy stored in the actuator. In my work, I suggested this topology. So we would have two main converters. First, a DC to DC converter to increase the voltage from 48 to 1 kilovolt. Then multiple DC AC converter for each actuator to be able to set the actuation time at 1 millisecond, and also to permit the possibility to restore to recover the energy stored in the actuator. And finally, we add multiple capacitors in order to store the energy recovered without the need of over-designing the DC to DC converter, which permit us to reduce the total cost of this converter. So now we'll try to present each converter. So first I will start with the DC to AC converter. So as I said before, the DC AC converter, we set its main task is to set the actuation time at 1 millisecond. Here we consider load capacitors because we don't have yet the piezo actuator, but in low frequency we can modelize a piezo actuator by a single capacitor. So to have 1 millisecond, one possible solution, we could use the resonance between the inductor and the capacitance. But the problem here is that we would need a very high inductor, which could compromise the size. So instead, we suggested to introduce an output current control in order to obtain a time actuation of 1 millisecond without the need of a huge inductor. To validate this topology, I designed the first prototype of the DC-AC converter, where I tested on the capacitive load with the same value as the capacitance of the piezo actuator. And here, as you can see, the experimental result obtained, we were able to obtain a time rise of 1.1 millisecond. It is not exactly 1 millisecond, but at least it is very near, because here we didn't consider in detail the output current loop. And with this result, we were able to present two conference articles. What's here? Can you hear me?
Yes, we can.
Yes, Nassim, we can hear you.
Okay, sorry. I thought there was some problem. Okay, so sorry for this misunderstanding. So as I said, for this work, I was able to publish two conference papers, and actually I'm trying to work on a journal paper on the second version of the prototype for the DC-AC converter, where here we try to improve the usage of this converter and also the performance. Now let's talk about the DC-DC converter, which is the most important, the biggest challenge here in my PhD topic. So the DC-DC converter will increase the voltage battery from 48 and provide an output voltage of 1 kilovolt. And here we have some major challenge. Amongst them is that this converter need to work on a large power range between 0 up to 200 watts. So I choose this topology because it offers a much higher gain compared to other topology in the literature. We could use a small injectors, so which means we would have a DC-DC converter with lesser size, and also this topology is expandable, meaning if you want to aim for another version of this converter, we could expand it and try to improve the performance of the DC-DC converter. And to validate this topology, I designed the first prototype, and I tried to measure the efficiency from 20 watt to 200 watts. So here we have a promising result. The efficiency in general is higher than 93.6%. And to be honest, it was really impressive, considering this is the first prototype of the DC-DC converter. Actually, I submitted a paper for an international conference on this work, and in the beginning of the next year, I will try to work on another journal paper, but this time on the conversion activity, meaning the DC-DC plus the DC-AC converter. Now I'm trying to work on the second version of the DC-AC converter, as I mentioned, until the end of the year. Then I will try to write and finish the journal paper on this converter. Between the two periods, I will try to test the DC-DC with the DC-AC converter, and then I will try to submit a journal paper on the conversion architecture. And finally, in the beginning of the third month, I try to write the thesis manuscript until the end of the year. And thank you for your attention.
Thank you, Nassim, for this very interesting presentation. Do you have any questions for Nassim? Okay, so there is no questions for you, Nassim. Maybe if there is question, you can answer after in the break or something like that. So thank you again for your presentation. So now we can move to our second speaker, Khabouri Imen, which is PhD candidate at the National Polytechnic School of Algiers. And her talk will be about the development of approach for the control and the optimization of the stick-slip phenomenon during drilling. So as a reminder, you have 15 minutes, Imen, 10 minutes for the presentation and 5 minutes for the question.
Okay, thank you. Hello, guys. First of all, thank you for the invitation. And I would like to start by presenting myself. Okay, my name is Imen Khabouri, and I am a PhD candidate at l'École nationale polytechnique in mechanical engineering. I did 2 years of preparatory school at l'École préparatoire en sciences et techniques de Tlemcen, and then 3 at l'École polytechnique de Constantine, and then followed by a PhD in École nationale polytechnique d'Alger. My research focuses on drill engineering primarily, and it is about the development of a control strategy to mitigate vibrations in drilling, more specifically the torsional vibrations. Okay, let me start by presenting. Sorry, I think you can see this now. Okay. And so, the development of an approach or strategy to mitigate vibrations in drilling includes actually, first of all, understanding what the drilling assembly is like. The drilling assembly is composed of several drill pipes stacked one above the other. As you can see here, the drill pipe is followed by a certain, like stiffer sort of drill pipe, which is called the heavyweight, followed by something else that is also a heavyweight, as another heavyweight is stiffer, and is attached to a drill bit. So when you're drilling, for example, for the exploration, you have two types of drilling. You have the first one that is exploration, you're exploring the area you're drilling. And the second one is development. So first, you start by exploring the area. You're looking for whatever is there, oil, is there gas, and then you do the development. In the exploration part, you mostly use like vertical ones. Vertical is the middle one, this one, vertical drilling assemblies. And sometimes you're stuck, and you have to actually use horizontal drilling assemblies. And the transition between vertical and horizontal drilling assemblies is that vertical has to deal with certain types of vibrations, which are axial and torsional, while the horizontal ones deal with axial, torsional, and lateral, but mostly lateral. What is the difference between these three is that, for example, in my work, the stick-slip phenomenon is due to torsional vibrations. Stick and slip exactly means what it actually means in English, which is stick, which is the drill bit is stuck into the formation. it slips into the formation, but then again, the speed at which it rotates, the speed at which the whole assembly rotates is bigger. It's 5 times the one that's given by the motor here, and that induces fatigue to the assembly, and it also induces a breakage into the drill pipes. And sometimes if a drill pipe is maybe breaks in the middle or at the end of it, at the drill bit, it cannot be recovered. And that costs a lot of money, and it costs a lot of wasted time, and the impossibility of reaching the oil and gas parts and the actual recovery of it. So you have, for example, here, different stratigraphic formations. So you have several ones. And the main point of our study is to not only mitigate, since it is a practical field, mitigating vibrations also means that you have to take into consideration maximizing profit. This work has been suggested by Sonatrach, and therefore the aim was to actually develop something that will be useful for the industry. And for something to be useful in the industry, you have to take into consideration several objectives. Maximizing the rates at which it penetrates into the rock, and also minimizing the vibrations and minimizing the time wasted, which is non-productive time. The aim of my study at first was to develop a rate of penetration into the rock that is based on historical data, which led to a development of a paper. The rate of penetration holds a significant importance in drilling because it assists in alleviating concerns. It also is a function of several parameters that go into the making of the drilling process, which are the weight on the bit, the weight on the bit, the rotation per minute, the fluid data, the vertical depth, and all of these things, they make not only the ROP, which is the rate of penetration, but they also go into the vibration estimation and the vibration model. So the first aim was to develop this rate of penetration, and I am going to share with you something else. Sorry. Yes, I think this is it. This is the paper for you to understand exactly the strategy. I don't know if you can see can you see the model development flowchart? Can someone tell me? Yep. Okay, thank you. And so, based on historical data, based on the historical data, we can make up a model that we can predict with it the rate at which the drill bit penetrates into the formations. And this is the model for the development of it. This is the model development flowchart that gets from like data to the actual the model developed. I don't know if I should go into details for this. But yeah, thank you for this suggestion. So we start by, since it is a highly noisy kind of process, you have to go through a filter, which is for the industry, for the drilling industry. It is highly recommended to use several according to whichever works for you. We've used several denoising filters, but this one works for us, which is a Savasi Gulai. And then we randomly split the data, and we through training and validation, we made out the model, tested and evaluated. And after that, like every formation in Algeria, we have 13 or 14 formation types. For every single formation, we have a model. You can find different works that have different approaches. Ours is basically on having models for each formation, but you can find others where there's a model for every single, it takes into consideration every formation. It is like a universal one, but this approach is for us the best approach as to deal with vibrations afterwards. And as I said, like the model development, the development of an approach to mitigate the vibrations, it has to consider ROP and then go into the optimization part, which is optimizing vibrations and also maximizing ROP. In order to maximize vibrations, you have to actually model them first. There are several approaches of modeling the vibrations. You can model the whole structure. You can model the whole structure as a finite element model with every single part of the drill bit, because the drill pipe is 9 meters in length. The drill string assembly can go to 7,000 feet. So it's maybe 300, 400 drill pipes. They can be modeled as again, like modeled through finite element methods, or they can also be modeled according to stiffness. And usually that is a 4 or 5 degrees of freedom model. And that way you can estimate the speed at the drill bit, or estimate the speed at any given point you want to estimate the vibration severity. And then by estimating the vibration severity, you can make adjustments with the ROP, make adjustments to the parameters like weight on bit or speed or any given independent variables for you to maximize the ROP and minimize the vibrations. Now, this is our approach. There are several approaches to mitigating vibrations. There are even tools that were developed not long ago. For example, the Tomax anti-stick slip tool. As I said in the beginning of the presentation, there are optimizations by means of redesign. So that means that you restructure the whole structure. You restructure it to see, and you benchmark it and see if it actually brings any better performance. But our approach was more on the active control and not the passive control or the benchmarking, because we do not have the possibility to even benchmark it here in Algeria. We cannot. It's not just us, but it is very hard to contribute to this specific area, if not by going to do active control. And hopefully in the future, we're going to be doing, this is my first paper, and the second part of my work is going to be about the ROP model with the vibration estimate model, and doing a multi-objective scheme to find the best candidates, the best independent variables according to what we want, according to maximizing and minimizing the vibrations. And I think that is it. If you have any questions, don't hesitate. And thank you.
So I don't know, we don't have questions, but we have a recommendation from Nadia Modem. So she writes interesting work. I highly recommend finding out more about the same work being done by neighbors industries in USA.
Thank you, Nadia. I think I've seen this works before. I think that, as I've said before, industries, because this is like a very niche industry, so even like the contributions that we have to make, they have to be specific, and they have to not be because we're researchers and we're not within the industry, so it is pretty difficult. But I think I'm going to take this into consideration. So thank you very much.
Any other questions for Imen, maybe? No questions? So we can move to our last speaker, the last speaker for the first session, Abdi Salim, a PhD candidate at Eindhoven University of Technology, and his talk will be about the photonic integrated circuits from concept to real-world application. So you have 15 minutes, Salim, 10 minutes for the presentation and 5 minutes for the question.
All right. All right, can you see my screen?
Yes.
All right, Assalamu alaikum wa rahmatullahi wa barakatuh. I am Salim Abdi. I finished my material science engineering degree from Polytechnique in 2013. Then I continued my master's in Polytechnique Montreal for 2 years in nanomaterials. And now I'm doing a PhD or finishing up a PhD on photonic integration in the Eindhoven University of Technology in the Netherlands. So basically, since the field is not really very well known, I wanted to basically introduce the field in a full presentation so that people know that these kind of things exist, and maybe to draw attention to the field as well. So try to have some pointer as well. So what are photonic integrated circuits? So if you imagine like an electronic chip that exists in your phone or computer, a photonic chip is a chip that works with light instead of electrons. So it can be versatile in terms of applications, and also it works in the speed of light, which is very much faster than electrons. The idea about integrating is the same as integrating different components into a single chip for electronics. So basically, you can have different functionalities in the same chip, and with that, you can have multiple, applications or complex circuits that deliver functionalities beyond, let's say, traditional ones. And basically, if you can have like different components in the same chip, basically you can miniaturize and make the chip even smaller, so that you can introduce it into novel applications. So for example, this I'm showing here the total component count of photonic components in a single chip and how it evolved throughout the history. And you can see that it's going the same rate or same exponential rate compared to electronic chips. So basically, you can have different functionalities. This is why these photonic integrated chips have been used, a lot in data communication to basically transfer the data from the fiber, which is light modulated, to the server racks, which save the data electronically, so via electricity. So but basically, by making a lot of components in a single chip, you can have complex circuits, and with that you can have a lot of other applications that have emerged throughout the years, like LiDAR, which is a way to have accurate measurement of the distance and objects of beyond the vehicle. So this is very useful for self-driving cars, for example. Biosensing, there's you can have chips that work for artificial intelligence to do very efficient matrix multiplications, and you can have also chips for quantum computing with these devices. This is just a small example of applications. So what is the difference between a photonic chip and an electronic chip? So if you see here, I'm doing the basic building blocks of an electronic chip and comparing it to a photonic chip. So for example, a transistor is converted to an optical amplifier. So basically, if you apply electricity to the optical amplifier, you can amplify the signal that is passing through it. And if you don't, the signal will die out. A resistor is converted to a phase modulator, where the phase of the light is changed, and with that you can have the same functionality as a resistor. A capacitor is a polarization converter, and an electrical connection, where the electrical connection or an electrical wire where the electricity goes through is simply a waveguide, where the light travels through the waveguide to basically carry out the information. So how do these look like? So for example, an optical amplifier or laser looks like this, and in a real scanning electron microscope image, it looks like this. And this is just an example from a platform. There are many platforms. The detector also looks like a small, like an amplifier, but different epitaxial stack. A modulator as well. You have passive waveguides. You have waveguides that are specific for bending the light, because it's difficult to bend light. Then you just have, like, for example, electrical wire. If you bend it, you still have the electricity going through. And the polarization rotator, because you have two polarizations of the fundamental modes. So basically these are just basic building blocks that you can assemble together to have a complex circuit that delivers a functionality. Now, if we move on to the life cycle of a photonic integrated circuit. So usually, if you have an application in mind, you want to introduce a product to the market, you start first with a design. So the design of a chip, you can either do it yourself, or there exist some companies that can do it for you, because basically it involves having the basic building blocks, connecting them together, making sure that all the functionality is preserved. So it can be challenging, but still doable. The fabrication, usually fabrication is done by companies, because it's very complex, and we will go through that in general. But in some specific cases in R&D, you can do it yourself as well. So fabrication, for example, there are many companies in Europe that does the fabrication, like Smart Photonics, Lyonix, and other companies as well. And then, for example, you have a chip that you fabricated. Now you want to package it to have a certain module that you can basically sell to customers. So this is where packaging and testing comes along. And packaging means that you assemble the chip in a certain package with the electronics, with the driving electronics, and other aspects, like how do you input the light into the chip. And with that, you can have a full module that that is functional and delivers the right functionality as you designed it. And then finally, you finish off with the application that you have in mind. So, for example, these are some of the companies that exist within the Netherlands for delivering different applications. And then, so if we move on to the design, the first phase, so basically you first want to make sure that all your basic building blocks work. So you can you do simulations of the basic building blocks, like simulation about light, about how efficient it is in terms of electrical injection, how much does it heat up, stuff like that, to make sure that it's working within the specifications. Then you move on to the circuit concept. So if you assemble all of these building blocks together, how does it function, and how does it, what are the drawbacks, what are the limits, and what can be the expected functionality of the full chip, so that you see if it's realistically doable to have this or not. And then finally, you can draw the layout of the chip. So for example, here, this is a chip that is made for 8x8 optical space switch. So it's just a complex switch that you put light, for example, in one of these inputs, and you expect light out of one of these outputs. based on how much signal you give into these blue building blocks. So then if you have the full layout, you can move on to the fabrication. So fabrication is done in the clean room. It is a place where you have very good control in terms of the number of particles that enter the place. So it means that you can have a very clean way to really fabricate the chips, because, for example, as we discussed, the waveguide that is used to drive the light in and out and within the chip is even 400 times smaller than a single human hair. So it is very sensitive to the number of particles that you have in the environment that you work in. So this is a way to basically limit the number of particles. So when you finish the fabrication, you have a full wafer that has multiple devices and multiple circuits in it. You can dice the wafer into small chips, and then you can move on to the then you can move on to the packaging that we will discuss later. The idea about companies that does the fabrication for you is that you can join the multi-project wafer runs of the companies. So basically, they assemble different circuits in the same wafer, so that basically they reduce the cost significantly of the same of the chip that you want to fabricate, and with that you can have access to the technology with a reduced cost. So with that, basically you can get like well, it's still expensive, but it's yeah. For example, usually it's around 10,000 euros for 4 or 5 chips in a research stage. Then it's basically when you validate that, it can go even lower. Now we move on to the packaging, testing, and commercial devices. So once you fabricate your full wafer, you want to do testing on it. So for example, here we have a simple passive waveguide. So you can see that you have an optical fiber in and optical fiber out, and you can just measure the properties of the waveguide that you fabricated. For example, how much does it lose in terms of light? So for example, you input light into the waveguide, and then you see how much it loses light. Next, you want to also do automated testing, especially for big volume manufacturing. Now, if you have validated your design and you have diced your wafer, we move on to the packaging, where basically you just package your wafer, package your chips into a special box that contains all the other components, like components to control the heat, components, electrical components to basically drive the photonics. The box is usually made out of gold to basically make sure that there are no electromagnetic radiation coming out from the outside. And then you also have basically an optical fiber into the chip, so that you can drive the signal in and out. And finally, some applications, as we said, like there are already quantum processors that exist with these devices. So the idea is that you have reliable qubits, but you can have good error correction into them. And then basically, because the fabrication is doable on a large scale, you can have good error correction. So basically, you can have scalable quantum computers in the future. So that's an idea where a lot of startups are doing this technology. There are also LiDAR for self-driving cars. So existing commercial devices, like let's say, like for example, Volvo has these LiDARs already in their cars. And then we have also the classical transceivers. So for example, here, this is a special, it looks like a USB, a special USB that basically converts the electrical signal to a photonic signal, and vice versa. for data centers at a very high speed. So, for example, the usual technology in this data center right now is 800 gigabits per second, and it's moving to 1.6 terabits per second using these transceivers. So, how do you, if you want to study and work in integrated photonics, what you should do at a bachelor's level, you can work in applied physics, material science, or nanotechnology. You can also work in electrical engineering, mechatronics, or telecommunications, and this is, usually much more useful than this. You can also work in industrial engineering or a business study like finance or marketing, and then search for a master's offering entry to the field or adjacent fields like nanotechnology or something like that. So I think that's it for me today, and yeah, if you have any questions.
Presentation. We have a question from Abdelhai Ben Ali. He wants to know if, just to be sure, is 5 better than 1?
No, just for the feedback. Sorry, for the feedback. I don't know which one. It's from
Okay,
1 to
you are
5.
asking. Okay, it's a
Yes.
mistake from my part.
If you can just add which one is better, 1 to 5.
Okay, no problem. So I think that we don't have questions for you, Selim. Thank you again for your presentation. And now we can move to the second part of the program, which is
there's just like one question here.
Yes, from Nassim Ryan Ben Nasser. So I'm curious if there is also other activities regarding the fabrication of power electronic devices such as GAIN and SiC transistors, since the process is almost the same.
Yeah, so you can see here, like you are discussing about gallium nitride or silicon carbide. Usually, each of these is a material system that is being done in a specific tools and specific clean rooms. So for the Eindhoven University of Technology, we don't really do power electronics, or at least we don't really fabricate them ourselves. But there are groups that does the studies on power electronics. But in terms of fabrication, I think there are more universities, for example, in the Netherlands, other places where you can, either specialize in fabrication or characterization or, realizing circuits with, these devices. Yeah, no problem.
Another questions, maybe, or to move to the other part of the other questions from Rebhi Amin. What about AE application?
Yeah, so there are many groups that specialize into AI. In terms of research only, like computational AI. But in terms of hardware, yeah. So basically, there are we do also like fabricate chips that are specialized for AI. So the idea is that you have chips that instead of doing electrical operations, it does photonic operations to have these efficient matrix multiplications. And there is ongoing research on that. I'm not really into that field. I'm more into data centers. But yeah, there is, and there are also startups in the field specializing for photonic chips for AI, basically.
Okay, thank you. Other questions? No more questions? Okay, thank you again, Selim. We can now move to the 3-minute speech session, and our first speakers, Talakji Sana Najet, PhD candidate at the National Polytechnic School, and her talk will be about the recovery of wastewater treatment plant sludge within the framework of sustainable development. So you have 3 minutes, Sana, and 2 minutes for answer the questions.
Okay, thank you. Hello, everyone. First of all, I would like to thank the PAC team for this opportunity to exchange and share. I'm sorry, I can't turn on the camera because I'm a bit uncomfortable. So let me start by introducing myself. My name is Sana Najat Salakji. I graduated from ENP Algiers in environmental engineering in 2021, and I am currently pursuing postgraduate studies on the valorization of wastewater treatment plant sludge as part of sustainable development. So I choose a 3-minute presentation because I'm in the early stages of my research. This topic is part of PRFU projects, which means University Research and Training Projects. These projects address issues proposed by the state for which we aim to find solutions. So let me explain further. As you know, wastewater treatment at treatment plants generates treated water and sludge, which is essentially the concentrated pollution that was present in the water. This sludge poses a problem because its management is not regulated under Algerian law. Currently, it is dried and set aside as treatment plants. For your information, the quantities of sludge generated are significant, amounting to enormous volumes across the national territory. This is precisely the focus of my research project, to propose a feasible solution. The project involves the energy recovery of sludge through anaerobic biodegradation and the collection of the biogas produced, methane, which can be used as an energy source. Of course, this process is already implemented in other parts of the world. It's not new. However, as you know, originality is key in research. I am therefore working on the impact of the sludge treatment process on biogas production. I compare the quantity of biogas produced from two wastewater treatment plants with different treatment processes. The first is the Bnimesus plant, which treats domestic effluents. Its sludge treatment process includes thickening, stabilization, and dewatering. The second is the Raya plant, which treats both domestic and industrial effluents. Its sludge treatment process involves thickening, storage, dewatering, and drying. So my approach involves collecting the substrate, conducting characterization. The analysis I am currently performing include measuring dryness, pH, volatile fat acids, titre alkalimetric, and chemical oxygen demand. And tasting biodegradability while collecting and analyzing the biogas produced. So at present, I am about to repeat the experiments to confirm the results I obtained last year. So the work is ongoing. I am in the middle of the experimentation, and I hope to make significant progress during this academic year. This is a brief overview of my research project. So thank you for your attention.
So thank you, Sana. There is any questions for Sana? Any questions for Sana, maybe, from the audience? Okay, so now questions for Sana. We can move to our second speaker, Hamidatu Lakhdar, who is a PhD candidate at Politecnico de Torino, and his talk will be about photovoltaic panels cooling kit. So you have 3 minutes for the speech and 2 minutes to answer the questions. Thank you, Lakhdar.
Okay, Assalamu alaikum. I hope you're doing well. My name is Lakhbar. Can I present or can I share my presentation to this page?
Yes, for sure.
Yeah, okay. So, share. It's clear. Can you see the presentation?
Not yet. Maybe you have to click on no. Ignorer, maybe.
I don't know.
I don't see.
I mean, we can see your screen, but not the presentation.
Ah,
Yes.
my screen. I don't know. How can arrêter la présentation? To l'écran. Fenêtre. Voilà. Yes. I think that it's
Yeah, now we can see your presentation.
okay. Okay. So, Assalamu alaikum. Before I start, I want to thank all the organization team for organizing this wonderful event. And I want also to present my gratitude for the opportunity to be here. And I want to apologize because I'm a little bit sick and my voice distracted under the weather. So, but I'm excited to present and to be contribute in this presentation. This presentation will be, I will present my project named by KRF. It's a photovoltaic panel cooling kit aimed to cool down the photovoltaic panels. I think that every person in the photovoltaic sector knows exactly that the temperature is a major issue in the solar plants. But before I start, let me present to you a short career summary. I've studied my preparatory class in the National Polytechnic School. After that, I specialized in energetics at the National Polytechnic School of Constantine. This project is my master thesis project, and I held the position of the energetic and HVAC engineer. After that, in this time, I prepared to be a PhD student at Polytechnico di Torino. So regarding the project, Kiref, it's an eco-friendly and innovative solution that prevents overheating, boosts energy efficiency, and extends the lifespan of solar panels. But before we dive into the technical details, let me tell you a fun fact. Kiref, regarding the name, inspired from the French term kit de refroidissement, which means cooling kit. So I think that I've inspired the name also, not just the product. So what is the problem? The problem is the high temperature reduce the solar panel efficiency and accelerate the degradation rates, which affect to the long-term investment. We can see when the temperature rise, the power generated by the photovoltaic panels directly reduced. So what is the solution? It's a cooling kit designed to cool down the photovoltaic panels and ensure an optimal performance in high temperature environments. More than actually over 30 papers have been exploited to develop this product, and we've studied the integration between phase exchange materials and the photovoltaic panels. We've developed this product and tested them with our own experiments protocol in the laboratory of National Polytechnic School. I think, yes, I think how does this product work? This product will be installed on the back of the panels. The phase change material kits will absorb the heat from the photovoltaic modules, and during the night, the kits will release the absorbed heat daily to be fully reusable for the next cycle. This kit can recover 5% of the power generated by the photovoltaic panels and can reduce the temperature by 12 degrees Celsius. It's regarding the technical features. This kit will use the paraffin and beeswax as a phase change material, and he have a low weight and a compact dimension to be adapted with the photovoltaic panels. Regarding the solution existed for the using actually for the cooling of photovoltaic panels, there is a competitive landscape, but they are usually struggle with a high energy and a complex installation. They need an excessive maintenance, which limits their scalability. For example, there's a French company that used the water to cool down the photovoltaic panels. And when we say the water, we need a water pump, actually, and a complex installation to use this solution. But what we bring to the table, we provide an innovative solution, a recyclable and replaceable, scalable and customizable solution regarding the needs of the clients. And we present a durable and unlimited lifespan for our product. Actually, we touch several parts of the global sustainable development goals. We present a clean energy. We contribute in the climate action, and we protect the lifespan on land. Alhamdulillah, we achieved some competitions. I'm the first Algerian who won the ENI award. It's an international and prestigious competition presented by the Italian president. I've already presented my solution to the president of the Algerian Republic, and I named by the Startup of the Year organized by Total Energy. We deposited our solution in the INAPI, and I will publish our first paper in the next few weeks. We've got also a label of Project Innovo, Projet Innovo, which is an innovative project from the High Ministry of Startups. Of course, there is an academic connections because I have a consent letter from University Malaya, which ranked 16th around the world. There is other interest from King Fahd University and Concordia University from Montreal. And I'm also excited to share these insights and knowledge and this journey with students to make them and to help them to avoid the mistakes that we've made. All this journey will be presented from my guidebook named by From Aspiration to Achievement. I want to thank you for your time and attention. And if you have any question, feel free to ask.
Thank you so much, Lakhdar, for your presentation. So we have questions or comments from Rabhi Amin. So the first one, what is the maturity of the project, technology, readiness levels? What is the impact on overall cost of PV in terms of percent of price and PV panel? And did you start commercialization? And the last one, don't forget to apply for the international IP coverage if not done already. So what are your comments, answers to the question?
Yeah, thank you. Yeah, thank you very much for your question, Mr. Amin. Regarding the project, we have a laboratory prototype. We don't have until yet our industrial prototype to be used in the effective solar plants. So we have a prototype used in the laboratory. Regarding your next question, actually, I just wanted to remind us this presentation, it's a general presentation. I didn't provide a deep presentation for the technical research because I want to make all the type of audiences engaging with this presentation, as I mentioned. So the next question is, what is the impact on overall cost of the photovoltaic? The impact, actually, we cannot calculate the directed impact regarding that because this kit will be adopted and we can add them to and we can integrate them with the photovoltaic panels. So if we use them, we can use them in the hot climates, for example, but we cannot use them in the European climate. So to calculate that, we have a cost, actually, a business model regarding the primary materials and the effective investment or return on investment regarding this. So I think that there is several details that we need to use them. But if we can speak regarding the business model or the prices, prices that our products, we present one kit and we recommend one kit per 18 watt for every photovoltaic panels, and one kit will be priced by €1. So I think that we need more details presentation for that. did you start commercialization? No, not yet. We didn't start our commercialization until yet because we need a direct convention with the global companies like Sonatrach or Sonalgas. They are our major clients, and we always eager to make a convention with them. Don't forget to international IP coverage. Of course, we have the interest to apply for an international IP, inshallah. Thank you very much for your question. And I hope my responses covered all your questions. Thanks.
Yeah, so thank you, Lakhdar. Maybe we have two other comments. So comments of Amin Rabhi. Thanks. So next step is to test in a field environment, Sahara Desert, for example.
Yes, we should. The next step is to make our prototype applying in the industrial landscape, of course, in the Sahara Desert, to make our solution and actually to make our results more adaptable with the climate's need, because there is a various climates that we should use, and we should test that in this solution. Thank you for your comments.
Okay, we have another question from Nassim. Very interesting topic. Are the schooling materials exclusively used for PV only, or can they cover a much larger field of application?
Yeah, great question. Actually, the phase change material can be used in several applications, but we always need to see the thermal characterization of the phase change material that we can use in the application required. So in this project, we've used the beeswax because it's a very adaptable and have a high conductivity and have high thermal characterization to be used with the photovoltaic panels. But in general, the phase change material can be used in several applications. The main character is the temperature diffusion. So it's the main type or the main character to be studied and presented to be used in the application need.
Okay, thank you so much, Lakhdar. So now we can continue with the last 3-minute speech presentation with modern Nadia, PhD candidate at the University of Texas, USA. And her talk will be about the storing CO2 underground climate solution. So Nadia, you have 3 minutes, 5 minutes, 3 minutes presentation and 2 minutes to answer the questions. Thank you.
Sure, thank you so much. So just a moment, I share my screen. Can you see my presentation? The PowerPoint?
Yes.
Oh, wonderful. Thank you. So, Assalamu alaikum, everyone. Thank you so much for the invitation. It's such a pleasure to get to know everyone and to listen to such brilliant work. My name is Nadia Mu'adhin, a PhD student at UT Austin, University of Texas at Austin. I'm a reservoir engineer, like a petroleum engineer by background. I got my master's from Algeria in Lianash. What I'm working on is related to storing the CO2 in the subsurface, which we consider as a climate solution. So I'm gonna try to make things easier just to introduce the topic. And if you wanna know more about it, you can just reach out to me and I can have more about it. So first of all, let's just talk about what is carbon capture and storage technology. We call it CCS. So it's a technology where we first capture the CO2. We capture it directly based on different techniques from the source of emission, which can be, for example, like I'm showing here in the picture, cement manufacturing plants. Then we compress it and we transport it. Mainly, one of the technique we use is transported using pipelines. And the last step, which is the focus of my work and the presentation, is storing it in the subsurface. We have different places where we can store it. First, it can be saline aquifers, which is a water like salty water layer, which is deeper, not the fresh water we drink. And we have depleted oil and gas reservoirs. It's like the reservoir mean the place from where we get the oil and gas. It is inside pores. I will explain the concept of the reservoir. We get the oil and gas out, we produce it, and then we are leaving like relatively free space. So we put the CO2 there so we can store it. And we can also store it in the salt bed, which is like the salt layers where the CO2 gets interacted with the salt and be trapped. This is how, just a minute. This is how the one of the conceptual models for the reservoir, like how the oil and gas is in the subsurface, is not like a big pool, it's more like pores. You can imagine it as a sponge. It's a different grains that got deposited with time, and it will be compacted, and there is a space between the pores. This we call porosity, and this space sometimes is connected and creating channels. The oil will be like trapped there. So why is it important to know about CCS, which is carbon capture and storage? It's like CO2, as we all know, is the main greenhouse gas that can cause the global warming that we are suffering from. And the CCS can capture up to 90% of this CO2 that is emitted and stored safely in the underground. So as you can see, on 2015 in Paris, like a lot of countries, almost like 194 countries, they agreed on working together to meet a goal, which is having a net zero target, like having as close as possible zero emissions for CO2 in the atmosphere. And as you can see in the image I'm showing or the plot, the goal is to have like more than 5 gigatons of CO2 being stored by 2050. And this is like the CCS will be part of the efforts, aligning with other technologies like renewables, nuclear energy, and more. So without the CCS, a lot of like industries like cement that can produce essential materials will not be able to like reduce the emissions. So the idea here is we can have CO2 emissions from different industries, but we put all the effort together and we capture it from the atmosphere and store it in the subsurface. The thing that is worth mentioning that Algeria is one of the leaders in this technology. One of the projects, I don't know if you heard about it, it was a big political problem in Algeria back in like 2025 or 2010. So it was like in Salah project where like the idea was to capture the CO2. How they actually removed it from the oil and gas. Like we produce oil and gas in the south in Salah, and then they remove the CO2 from it and they store it back again in the subsurface. That could be a way, like to make it simpler. We have oil and gas deep down, so you put the CO2 in the edges, as I'm showing here in the plot, and the CO2 would push the oil and gas to be produced. So this project was successful. Then they had a problem. The CO2 leaked, like it has a path, so it gets to the surface. They stopped the project, unfortunately, but it's one of the big like icon in the worldwide, even here in the US and the Norway project that they learn a lot of lessons for monitoring the CO2, for the safety, how to store it. And even as a researcher, I'm still like taking this project as one of the examples to learn a lot of things. So overall, we can say that Algeria can lead the way in CCS for North Africa by building on the experience we have from Ain Salah project. And we also have enough resources to even do another project like that. And the great news that I recently read an article on LinkedIn that Algeria will build the second plant for storing the CO2. So as an engineer, this technology is not only for like petroleum engineers, it's an effort for all engineering concepts like chemistry, mechanical engineers, civil engineers, like everyone can be involved, electrical engineers. I don't know if I'm missing someone, but a lot of concepts that can be put together to have the perfect solution. If you are interested in this topic, please feel free to reach out to me. This is my email and LinkedIn. Basically, my research is how we can, in the storage area, this is where mainly the petroleum engineers are, because we have the knowledge of the subsurface. So, and we know how fluids can be trapped there, and how we can inject it and produce it later based on the pressures and the flow rates, control it. So my research involves how we can store it in more like challenging areas. I don't know if we have geologists among us here in the conference, but it's like sandstones with some shales. I think Iman, she talked a little bit about shales and how it's challenging. So I'm working on that, and as I said, I'm happy to connect with everyone, and thank you so much for the opportunity. If you have any questions, I'm ready to answer.
Yeah, thank you so much, Nadia, for your presentation. Any questions for Nadia? Maybe I can have one or two questions for you, Nadia. So what are the limitations of, sorry?
You have an echo.
Sorry, and now? It's better now? No?
No, sorry, we still have a hard time.
Maybe I will just write my question for you.
Oh, sure, yeah.
Okay.
I read it. Okay. The limitations, okay, I would say I will answer it in terms of challenges more than limitations. The technical part is it's a proven technology. We have all what we need to do it. It's like applicable in the US, Norway, like in more than like 190 countries. They did it and they could make it. The problem is regulations, is how to get the permits to do it. Even in countries that has like more flexibility in that is hard. It's first the society opinion, because like they are storing the CO2 and the CO2 is toxic gas, so it can leak to the surface. Like we have some cracks, fractures in the subsurface. It's hard to control it. Like it's a gas, it's low density, it can leak and go to the surface. That will be dangerous because it will be concentrated when we store it. That's one of the risks. The other thing is political. So it depends on the policies of each country, if you can do it or no, and where you can do it. The technical challenges is how we can keep it there. So we need to have some technologies, advanced one, to monitor it. Like monitor it just to the magic of oil and gas is that we are dealing with things we don't see it. It's in the subsurface, and we just do some measurements like pressure, sonic measurements, electrical measurements, and based on that, we are trying to understand what is happening. So this is one of the challenges. You need a lot of money to do that. It's costly. And yeah, the second question, the cost. I don't have in mind right now like the numbers, but I would say it depends from country to another, and it depends on, like, for example, in Algeria, they need to get the technology from like another country, so it will be expensive. It's not all things we can develop in Algeria in terms of like the tools. I know we do have the facilities. We do have a very brilliant engineers. They were able to implement the project, but the issue that is you need to have more like technologies to monitor it. That will be costly in Algeria. In Algeria, maybe in one country in the Europe or in the US, it will be less costly because they do have the technology built there. And like another reason about how being costly, it can be maybe the implementation of the plant itself, like from where we capture it and we transport it through the pipelines, and that could be another costly also area.
Okay, so thank you so much for the answers, and thank you for your presentation. If there is no other questions, we can take 10-minute break and continue with the full presentation, with the second session of full presentation with Ashwa. So if you don't have any questions, we can take the 10 minutes break. And just don't forget to provide your feedback on the past presenters or presentation by voting through the different links. Thank you so much.
All right, now moving on to the second part of the presentation. We will be having three presenters, starting from Sabah Jamal. He's a PhD candidate at University of Paris-Saclay, France, and he will be presenting about code smells detection using AI. Jamal, the floor is yours.
Thank you, Idihya. I'm just sharing my screen. All right. First, thank you for the CAP, for the PAC to organizing this event and letting us all talk about our research. So let me introduce myself. My name is Jamal Misbah, and I am a graduate engineer from Polytechnic Algiers from 2021 in electrical engineering, and I am now a PhD candidate in Paris-Saclay, as well as ISEP School of Engineering and at Servio Company. And today I'll talk to you about code smells detection using collaborative AI. So first, let us define what is a smell, a code smell. So it's certain structures in the code that may suggest the possibility of refactoring. So anyone who says refactoring, we are talking about technical debt. And it is also a surface indication that usually corresponds to a deeper problem in the system. And I want to emphasize the term usually, as sometimes it may not be an inherent problem. And I was thinking about an example to clarify that. So for example, the long method smell. So it's a smell where we have a method that contains too many lines of code. One might argue that we can decouple this long method by using multiple functions, but depending on the system we are working on, so for example, if it's a memory constrained system, typically in embedded systems, we wouldn't want to call it a smell and refactor it, as it may lead to many function calls, which may lead to stack overflow. All right. So talking about the existing methods that we use to detect smells, we first have the heuristic methods, such as SonarQube, Checkstyle, and PMD, that works on a manually based and crafted rules principle. It is always deterministic, and it is computationally efficient, as the rules are all predefined. But we have the necessity of always crafting these rules, and it doesn't generalize well to different code bases, as we always need the experts in order to guide and craft these said rules. What we also have is the supervised learning realm, where we are working on a classical classification task, where we want to detect smells using some prefabricated data set. Typically, what has been used in this area is using metrics, statistical metrics about the code base, such as object-oriented metrics, the number of line of codes, the number of methods in the code base, and many others. And we use typical machine learning models in order to train these models and be able to detect smells during inference. So before switching to what is used currently, I'll just talk about the data set collection. So when we talk about smell detection, there is no anonymous data set that is used in the research. And most of the data sets are based on proprietary data sets, which might not help leverage future explorations. And there are only two imbalanced data sets that are commonly used, which are MLCQ and DACOSQ. And the general process for creating a data set is principally constituted of two methods. One is the use of heuristics, such as the ones that we saw before. Specifically, in this case, we can see designite. The problem with using this method is that we are inherently introducing some biases. So at the best, the model can only learn what these tools are trying to do, and it cannot generalize and have some general knowledge about the code in order to infer new type of smells. And the other type of dataset creation is the use of manual labeling, where we gather experts in order to labelize all the different parts of the code base. But this is time consuming and subjective, which requires a lot of post processing in terms of consensus between what the experts have chosen to label as smell or not. Now we will talk about source code representation, which is like the current state of code smells detection. When we see a code, we can see it from a metric-based view, such as the one that we talked about before. But it's also a text composed of tokens, thus leading us to a lexical point of view. But furthermore, programming languages are formal languages, so they carry inherent syntactic meaning and a robust grammar. And this grammar can be captured by the abstract syntax tree, so the AST, which gives us the syntactic POV. And just for a little reminder, the ASTs are the output of the parsing process of the compilation. So here we have an example of a while loop in Python, and it's simplified between quotes corresponding IST. So this leads us to one of our first work, where we try to leverage both the syntactic and semantic point of view, first by building graphs from the ISTs that are fed to GCN. So this is a type of graph neural networks, specifically graph convolutional neural networks, and also the token embeddings for each methods that are fed to classical LSTM. And we make a fusion out of it and have a final prediction that gives us both views. And just for a side mention, for this study, specifically for the graph neural networks, we built with my colleagues framework that is built upon Apple MLX, which is MLX Graphs, and it's open source, so you can take a look on it. What we did is also another overhaul NLP study on these particular tasks. So we can see it as text classification tasks. And we used BLSTM to have a sequential forward and backward understanding of the snippet. Then we apply an attention layer to aggregate all the information of all the snippets into a single context vector that supposedly gives us a resume of all the code snippets. And we also did compare again using conventional pre-trained encoders, because if you don't talk about language models while they are trendy, it's not an honest study. and we specifically used the CodeBERT. So we can't use large language models as they are, as they are decoders, so they are primarily used for generation or primarily used for generation tasks. But we can use the encoder part that may give us an embedding representation of the sentences that we provide. And we did an ablation study on the MSCQ dataset and studying different parts of the models. So we compared against the baseline, which are the classical machine learning models, as well as the model that we provided, and fine-tuned CodeBERT. And also did take a look and an ablation study on using different tokenizers and also different embedding modules. Because when we talk about tokenizers, well, I can talk a lot about them, but when we are in a natural language paradigm, the tokenizers need to be able to generalize to different sentence and unknown also sequences. But in the context of programming languages, we have a set of predefined keywords that are already necessary. So we did an ablation study to enforce our hypothesis also on this part. So what about LLMs? So why consider LLMs? We can leverage deep understanding of code semantics from pre-trained models. So any LLM has been trained on all the internet, so it has for sure gotten its way in a large amount of code bases. So it has inherently and intrinsically learned programming languages. So hypothetically, they can help us detect smells. And it also minimizes the need for large level data sets, which is an issue as we talked about before, by using either few-shot or zero-shot learning. Thus, a comparison is needed, and that's what we did. Specifically, we used both GPT-4 and an open source alternative, so Meta's Llama, in its quantized form with 16 and 8 bits. And so this is the prompt structure. And the results are actually not that good. Specifically, in terms of alignment to the task, the model doesn't align well. So one can infer from this study that in order to leverage the LLMs, the part that follows the pre-training part, which is the RLHF, reinforcement learning human feedback, needs to be adjusted to this particular task. And this is something that we'll do in the future. Yeah. And particularly, Llama had a difficult time even aligning with the output format intending. And it provided excessive description and information on the code snippet. So as we said earlier, they are more capable in generation tasks than classification tasks. Another path that might be taken is going away from supervised learning paradigm and taking a self-supervised learning path, specifically through contrastive learning. So what we try to do is take the code smells detection as an outlier detection task. So after we have our embeddings that represent the smells in a latent space, as we can see in the figure, we can treat corresponding points that are outliers as possible anomalous patterns that suggest a potential smell. And in this particular case, we can leverage this pre-identifying process to an LLM so that he can also gives us his partial understanding of what has been detected, so as to leverage the generation abilities. What will also be done is on a following exchange with the Dalhousie University, we will try to work on detecting smells, but in an architectural way. Specifically, all the work that I have showed so far is in a self-isolated code snippet, and what we want is to have an overall representation of all the code base, so as to be able to detect design bad design practices in terms of design principles. And that's all for me. Thank you. If you have any question, feel free. So I see a question from Ryan. Can I answer it, Dia, or?
Yes, please.
Okay, so Ryan asked me, did you use Python? Do you think there is an advantage using C++, for example? So for our studies, we primarily relied on using Python. Although we had to do some implementations in C++ specifically for the I can't show anymore, for the MLX graphs package. So in order to leverage the matrix multiplications, the sparse matrix multiplications, as we have already talked about it earlier, we needed to implement some kernels in C++ and Metal, which is the CUDA analog to for Apple. And yes, so there is an advantage using C++, not specifically as using it directly, but making implementations that can be used then by Python, specifically linking it to a Python interface, and then we can use directly in the framework of our choices, such as PyTorch or MLX or TensorFlow or JAX.
Okay, so we have another question here. Ryan is saying, do you plan on deploying the solution for a practical use? And what would be the constraints from your point of view, maybe the inference or something else?
Yeah, so we are currently working on a project based on my works. And I can say that the constraints initially are indeed, so the model as itself, in order to detect smells, doesn't have particular constraints, but incorporating it into an overall ecosystem that can provide us all the inputs requires some engineering in terms of software engineering. And also, in order to have, so what we want to do is to have plugins, for example, to check PRs in GitHub, and have like recommendations about the smells that were found. So in that aspect, inference using large language models is indeed a big constraint. So we are working on building some small large language models that can fit easily in our constrained environment.
All right, thank you, Jamal. It was really very clear. Thanks.
Thank you.
Any other questions for Jamal? Okay. Thank you so much, Jamal. Now we can move to the next presenter. We have Tobel Mohammed Ayoub. He's a PhD candidate at ESPCI Paris, France, and he will be presenting Surface intelligente reconfigurable pour les réseaux 5G. You have 10 minutes to present and then 5 minutes for questions. The floor is yours.
Okay, merci Ashwaq. Do you prefer that I present in English or it's okay if I do it in French?
Whatever works for you, yeah, you could do French.
Okay, my slides are in French, so just do it in French.
Sure.
Okay. Ok, vous arrivez à voir mon écran?
Yes.
Parfait.
It's just not on present mode if you want to go to diaporama.
Ok. Là, c'est bon?
Nope. Maybe it's fine.
Bon, on peut faire comme ça.
Yes.
Donc, je me présente. Je suis Mohamed Ayoub Toubal. Je suis PhD student, donc travaillant sur ces surfaces intelligentes reconfigurables. Donc, c'est une thèse CIFRE entre le SPCI, l'Institut Langevin ici à Paris, une start-up parisienne qui s'appelle Greenwave. Donc, mon parcours, brièvement, moi, j'ai fait Polytech, du coup, entre 2016 et 2018. J'ai fait école préparatoire, puis j'ai enchaîné avec une licence à Marseille sur tout ce qui est électronique, électrotechnique automatique. Et puis, j'ai fait un master à Sorbonne Université sur les systèmes RF, donc systèmes télécom en général. Et donc, j'ai commencé ma thèse en 2022 et je suis à ma deuxième année de thèse. Donc, on va commencer avec un tout petit peu de physique, la physique de la propagation des ondes électromagnétiques. Donc, on sait que les ondes électromagnétiques se propagent à la vitesse de la lumière et se propagent un peu partout dans toutes les directions. Donc, Monsieur Fries nous dit que si on a une antenne dans un point A qui essaie de transmettre une onde électromagnétique à un autre point B, donc la puissance qu'on va recevoir au niveau du récepteur va être égale à la puissance transmise fois ce qu'on appelle la surface équivalente de notre antenne divisée par 4P d au carré. Donc, on peut vite conclure que la puissance va décroître suivant la distance entre notre antenne émettrice et notre antenne réceptrice. Donc, ici, j'essaie donc de clarifier ça en donnant un exemple. On a du coup une antenne qui transmet à 3 GHz. Donc, la longueur d'onde est de 0,1 mètre. À 1 mètre, on va recevoir que 0,005 de la puissance transmise, donc à peu près moins 43 dB. Et donc, si on veut recevoir à 10 mètres, cette puissance elle sera divisée par 100. Ici, on voit bien donc l'impact de la distance sur la propagation de l'onde électromagnétique. Ici, ce qu'on appelle l'atténuation des ondes électromagnétiques. Donc ici, à gauche, je montre un cas réel où on a donc une antenne, une station de base, généralement, qui transmet un signal vers un utilisateur. Ce monsieur-là qui tient sa tablette entre ses mains essaie donc de se connecter à cette station de base. On voit que à des fréquences qu'on appelle les fréquences.
Pardon, mais non, vous partagez pas le bon écran.
De quoi, pardon?
Vous partagez pas le bon écran, je pense.
Là, c'est bon?
Oui, c'est pas en screen, donc.
J'arrive pas à comprendre ce que tu me dis. Hein.
En fait, effectivement, on l'entend très mal. Il demande juste si vous pouvez partager votre présentation en plein écran, en diaporama, parce que là, on voit...
Je sais pas, j'ai essayé de partager. Peut-être c'est à cause de Google Page.
tout en bas, là.
No, I think what you can do is when you start sharing your screen, just share full screen, not just the slides. This way you can go into diaporama.
Okay, I'll do that. Si je fais présentation, écran complet. Histoire. Ok, on partage. Ok. Là, c'est mieux?
Yes,
Now it's full screen, right?
exactly. Thank you.
Perfect. Ok, donc j'étais en train d'expliquer l'impact du coup des obstacles sur la propagation des signaux électromagnétiques. Donc on voit ici qu'un mur peut atténuer notre signal de à peu près 20 dB, 20 dB, ce qui est vraiment énorme. Donc dans le contexte de la 5G, il faut savoir que la 5G, en fait, on a deux bandes de fréquences. On a ce qu'on appelle la bande FR1, c'est autour de 3,5 gigas. C'est ce qui est déployé actuellement en France. Et on a du coup la bande millimétrique, c'est entre 27 et 31 gigas. Pourquoi on a deux bandes? Tout simplement, ça dépend des use cases. On utilise généralement la bande millimétrique quand on veut envoyer disons, un grand flux de données pour des solutions de AI, réalité augmentée, des choses comme ça. Et donc, dans ce contexte de 5G FR2, on peut observer donc que l'atténuation de ces ondes électromagnétiques, elle est vraiment importante. Et on a besoin donc de ces surfaces intelligentes reconfigurables pour aider, en quelque sorte, si j'essaie de simplifier un peu le contexte, ces ondes à se propager dans l'environnement. Donc, ici à droite, je vois que si je rajoute une surface intelligente reconfigurable sur un mur, je peux facilement redistribuer, si je peux expliquer ça comme ça, mon signal qui vient de la station de base à l'intérieur de mon environnement vers ce monsieur qui tient sa tablette ici. Donc, il va pouvoir bénéficier d'une meilleure couverture réseau grâce à ces surfaces intelligentes reconfigurables. Donc, concrètement, c'est quoi ces surfaces intelligentes? Donc, une RIS, pratiquement, c'est 3 couches. On a la couche supérieure qui contient ce qu'on appelle des cellules unitaires ou des atomes. C'est des antennes patch, pour ceux qui connaissent les antennes patch. Donc, c'est ce qui rayonne en quelque sorte notre onde électromagnétique. Derrière cette couche, on a ces antennes patch, ces petits antennes patch. On a ce qu'on appelle un PEC. Donc, un PEC, c'est une plaque en cuivre qui permet de réfléchir donc l'onde électromagnétique. Et derrière ce PEC, on a donc tout ce qui est circuiterie, donc les circuits de commande qui vont programmer cette cellule unitaire. Donc cette cellule unitaire, en fait, on injecte dessus ce qu'on appelle des tunable elements. Ces éléments, c'est ce qui va permettre de changer les caractéristiques électromagnétiques dans notre atome aux cellules unitaires. Généralement, c'est des diodes ou ce qu'on appelle pin diode over actor diodes. Ces diodes vont être contrôlées donc, grâce à un FPGA et d'où le concept de reconfigurable surfaces. Donc, elles sont reconfigurables. On peut changer l'état de ces surfaces en utilisant, donc, comme je dis, des circuiteries de commande, des FPGA classiques. Donc, on a un design d'une RIS qui fonctionne dans la bande FR2 pour la 5G mmWave, à Green Wave. On a donc publié aussi un article là-dessus. C'est un des premiers designs dans le monde de ces surfaces intelligentes reconfigurables. Et donc, la surface intelligente reconfigurable, concrètement, elle ressemble à ça. Donc, on voit plein de unit cells, c'est ce que j'appelle atoms unit cells, les antennes patch sur la surface. Donc, la RIS de Greener-Wave, elle contient 1600 unit cells. Donc, ces unit cells, comme j'ai expliqué, elles sont contrôlées par des shift registers qui sont derrière la métasurface. Et ces shift registers vont être pilotés avec le FPGA, qu'on voit ici sur l'image à droite. Maintenant, parlons un peu de ma thèse. Donc, dans ma thèse, moi, j'explore un peu trois pistes. Comment on peut intégrer, du coup, ces surfaces intelligentes dans un réseau 5G commercial. Comment aussi on peut, du coup, caractériser ce qu'on appelle le diagramme de rayonnement. Donc, comment, en quelque sorte, cette surface, elle va réfléchir l'onde. Comment on peut calculer comment on peut modéliser, si vous voulez, cette réflexion et comment on peut développer, si vous voulez, des algorithmes d'optimisation des unit cells. Quel sera du coup le state de chaque unit cell afin de pouvoir faire de la formation de faisceaux vers un endroit désiré dans l'espace. Donc, je vais commencer donc avec la communication sans fil 5G, mmWave, commercial assisté par Cirrus. Le contexte, du coup, comme j'ai expliqué, comment on peut intégrer ces surfaces dans un réseau commercial et quel sera du coup l'impact de cette technologie sur le réseau commercial et finalement, quel sera aussi l'impact écologique de la RIS. Oui, pourquoi j'aborde cette notion, c'est très important parce qu'on a déjà en fait des solutions qui existent pour faire de la formation de faisceaux, des répéteurs Wi-Fi qui permettent du coup de régler ce problème d'atténuation, mais c'est ce qu'on appelle MIMO systems. Ces systèmes sont vraiment gourmands en termes de consommation d'énergie, donc c'est pas du tout écologique. Et avec notre solution de RAS, nous on produit pas d'énergie, on n'injecte pas d'énergie dans l'environnement, on réfléchit juste à l'énergie qui existe déjà. Donc c'est très très écologique. Donc, on a fait une campagne de test à Rennes. C'est une collaboration entre Greener-Wave, Orange et le SNCF, où on a du coup installé notre RIS, qu'on peut voir ici à droite, dans une gare de train à Rennes. Orange avait déjà installé donc sa station de base 5G mmWave dans cette gare et on s'est servi donc d'un smartphone 5G de chez Sony pour essayer donc de capter les signaux qui seront transmis par la station de base vers le smartphone via notre RIS. On a essayé deux scénarios où on avait donc une RIS à 21 mètres de la station de base et on a essayé donc de cacher notre smartphone dans une zone où on n'a pas de couverture réseau 5G mmWave. Et le smartphone, il se retrouve à peu près à 4 mètres de la RIS. Donc, grâce à, comme je vous ai dit tout à l'heure, grâce à des algos d'optimisation que j'ai pu développer aussi pendant ma thèse, on arrive donc à programmer cette petite surface de sorte qu'elle réfléchit le signal qui vient d'une station de base à 20 mètres, quand même c'est énorme, vers le smartphone. Et grâce à un simple outil qui s'appelle aperf, qu'on a installé sur le smartphone, on peut analyser donc le débit qu'on reçoit à partir de la station de base quand on a la RIS et quand on n'a pas la RIS. Donc, on a observé que sans la RIS, pratiquement, on reçoit rien. Si on fixe, vous savez, les stations de base, en fait, elles transmettent des données dans des beams, ce qu'on appelle des beams, et chaque beam a un index. Ici, on a fixé un beam avec l'index 20. On a essayé donc de mesurer le débit que ce beam va fournir à notre smartphone. Donc, avec la RIS, pratiquement, on reçoit rien. Et si on active la RIS et on la programme, on peut avoir une amélioration de 20 dBm, ce qui est aussi énorme. Et on passe à un dB de 500 mégabits per second. On a testé aussi un deuxième scénario où on a essayé du coup parce que là, sur le premier scénario, l'ARIS, elle était face à face par rapport à la station de base. Donc, on a une incidence normale de l'onde électromagnétique venant de la station de base. Là, on a essayé, du coup, d'avoir une incidence un peu oblique. À peu près, on a 20 à 30 degrés. Et on a aussi augmenté la distance. On est allé jusqu'à 30 mètres. Et on essaye donc, encore une fois, de réfléchir le signal avec le beam, si vous voulez, avec l'index 13 de la station de base vers un smartphone qui se trouve juste devant l'enseigne Yves Rocher, ici, vous pouvez voir sur la photo. Et pareil, on a essayé donc de mesurer le débit de la transmission avec APERF sur notre smartphone. On voit que sans la RIS, pardon, une petite faute d'orthographe ici, sans la RIS, normalement, on est censé recevoir moins 49, 44, 94 dBm. Sans la RIS, pardon, et avec la RIS, on peut du coup améliorer notre réception jusqu'à moins 72 dBm, à peu près 22 dBm de gain. Pareil, c'est énorme. Et on peut passer d'un dB qui est égal à peu près 0, enfin c'est des kilobits par seconde, c'est rien, à des dB allant jusqu'à 513 mégabits par seconde. Pareil, avec un logiciel commercial, on a pu observer le débit, le RSRP. Le RSRP, c'est Reference Signal Received Power, c'est un KPI qu'on utilise généralement dans le monde de la téléco pour un peu mesurer la qualité de notre transmission. On voit quand on a la RIS qui est en état off, donc elle n'est pas fonctionnelle, on n'arrive pas on n'a pas en fait, le smartphone, il n'arrive pas à loquer, à recevoir de la donnée à partir d'un BIM, donc c'est pas très stable. Une fois on a activé la RIS, donc automatiquement le smartphone, il arrive à recevoir des données vraiment sur le BIM 13 d'une façon stable, vraiment d'une façon stable. Et si on désactive encore une fois la RIS, bah, on revient à ce comportement instable par rapport au BIM. Et pareil pour le Reference Signal Received Power, on a une puissance toute pourrie quand la RIS elle est en état off. Et si elle est en état on, on arrive à passer à une puissance de 72 dBm. C'est parfait. Et encore une fois, si on la désactive, on a des puissances ça fluctue énormément. Le bitrate qui est à peu près proportionnel à cette puissance. Pareil, quand on est en état off, on a un débit pourri, on passe à un état on, on a un débit à peu près de 530 mégabits par seconde. Et donc, conclusion, la RIS, avec la RIS, dans un contexte de 5G mmWave, on peut faire de la formation de faisceau, on peut assurer une transmission de data d'une façon fiable, et on peut aussi limiter tout ce qui est interférence, parce que justement, ce comportement de instabilité au niveau de BIM index, il est dû à ce qu'on appelle multipath, donc les réflexions multiples dans notre environnement. C'est pour ça le smartphone, il n'arrive pas à recevoir, il n'arrive pas à stabiliser au niveau du BIM index. Il reçoit n'importe comment. Avec la RIS, donc, on limite ces interférences et on aide en quelque sorte notre système de communication à transformer de la data d'une façon fiable. Donc, mon deuxième axe, c'est la localisation et la rétroaction entre RIS et utilisateur. Donc, comment on arrive à contourner ce problème de blocage en mmWave et qui va contrôler du coup cette surface intelligente reconfigurable? Est-ce que c'est le smartphone qui va programmer cette RIS afin de réfléchir l'onde de la station de base vers le smartphone, ou bien c'est la station de base qui va donc lancer une commande à la RIS lui disant voilà, il faut faire de la formation de faisceau vers cet angle ou vers un autre angle. j'ai pu du coup développer tout un système où j'ai une station de base, une RIS et un utilisateur. L'idée, tout simplement, c'est d'avoir en fait deux canaux, two channels. On a donc le canal où on transmet de la data à 27 gigas, donc dans la bande millimétrique. Et on a donc un deuxième canal, on va transmettre des séquences de commandes depuis l'utilisateur vers la RIS. Donc, moi, j'ai essayé d'adopter l'approche où c'est l'utilisateur qui va commander la RIS. Donc, c'est l'utilisateur qui va dire à la RIS de quelle configuration il faut appliquer, de sorte que on va avoir ce beamforming entre la station de base vers l'utilisateur. J'ai pu développer oui.
Ayub, can we come to conclusion, please, so that they can ask some questions and then we conclude?
Ouais, c'était un peu long, pardon. Donc, ouais, je vais finir donc sur ce protocole que j'ai pu développer. Où on a donc notre user equipment, notre smartphone, qui va envoyer des paquets de données à la RIS, lui disant voilà, je suis à l'écoute, vous pouvez commencer à transmettre avec des beams préconfigurés. Et du coup, on va essayer de tester tous les beams et on va essayer donc de repérer le beam qui donne la meilleure puissance et le meilleur bitrate et donc appliquer la configuration qui correspond à ce beam. On a essayé donc de faire des mesures afin de tester la fiabilité de cet algo. On a pu avoir des précisions franchement parfaites. C'est de l'ordre de 2-3 degrés de misalignment. C'est la dernière partie, donc la modélisation. Comment on peut, en quelque sorte, calculer ce champ réfléchi par la RIS. Un peu plus poussé, comment on peut estimer le couplage entre ces unit cells et ces atomes. Donc, c'est une formule que j'ai pu développer basée sur Freeze Formula que j'ai présenté au début de ma présentation et la surface équivalente radar. J'ai pu faire des simulations afin de valider donc cette formule. On a pu avoir des résultats, comme vous pouvez voir sur mes slides, presque parfaites. On peut donc estimer la puissance reçue dans des endroits quelconques dans notre espace d'observation. Ça sera tout pour moi. Merci de votre attention.
Thank you so much, Ayub. The audience, do you have any questions to ask? Okay, we have one.
Oui, donc de quelle façon on programme le FPGA? Alors c'est un peu compliqué. Je ne sais pas si je peux repartager mon écran. Vous arrivez à voir mon écran?
Oui.
Oui.
Parfait. Donc, admettons donc qu'on a une antenne émettrice, en l'occurrence une station de base ici, une autre antenne qui reçoit ici, donc un smartphone. Si on a donc la position géométrique dans notre antenne TX, dans un système de coordonnées sphérique, cartésien, comme vous voulez, on a ce qu'on appelle le array factor. Le array factor va en quelque sorte nous donner une idée de comment ces unit cells vont travailler ensemble pour réfléchir, pour concentrer cette onde ici. Et donc, on va pouvoir extraire la phase de l'onde qui arrive sur la métasurface et la phase de l'onde qu'on va réfléchir. Donc, la différence de phase va nous donner les différents états des unit cells. J'explique ça vraiment rapidement. Donc, ces différentes states c'est vraiment les states des diodes que j'ai montré au début. Donc, si c'est à partir de ces phases qu'on va savoir quelle diode il faut activer et quelle diode il faut désactiver. Et donc, avec le FPGA, on va pouvoir envoyer des 1 et des 0 vers les shift registers afin d'activer ou désactiver tout simplement ces diodes. Mais voilà, si je fais une conclusion, déjà, on a un algo qui va déjà prendre ses positions, des antennes X, RX, calculer donc la phase de l'onde qui arrive, la phase de l'onde qui réfléchit. La différence de phase va nous donner les différentes states de chaque unit cell. Et ces states, c'est des 1 et des 0. Hein. C'est soit on active la diode, soit on désactive la diode. Et donc, avec le FPGA, on envoie ces 1 et 0 afin de les activer, les activer. J'espère que j'étais clair là-dessus. Parfait.
Perfect. All right. Any other questions? All right. Well, thank you so much, Ayub. Thank you to all the presenters. Now we can move to the other activity we have now, and we'll move to our panel discussion session. Shakib, if you can share your screen. The University of North Dakota in Energy Engineering, and I will be leading this session alongside with Sofiane. He will be introducing himself as well. No, we cannot hear you. No. Maybe turn off your mic. All right. So
Cannot
we
hear me.
have. Okay. Yeah. Sure. Yeah, you're good.
You can hear
Go
me
ahead.
now?
Yes. Great.
All right, great. Sorry about that, guys. So I'm Sofian Amroun, a third year PhD student at the University of Miami. I graduated from EMP in 2022 in civil engineering, and right now my research is about cementitious materials, and I will be moderating this session with Ashwa. So I will give a very brief introduction of our panelists. So the first one is Dr. Skandar Zouari, who's the Deputy Director of Information and Communication Systems and External Relations at Polytech Alger. He has extensive experience as a consultant and educator at different institutions like Neoma Business School, and our panelists will have the opportunity to tell us more about themselves. This is just a very brief introduction. We have also Professor Taous Mariam Lalek, who is a senior researcher at the National Institute of Research in Digital Science and Technology in Paris-Saclay. She's a former associate professor at King Abdullah University of Science and Technology, specializing in control theory, signal processing, and bioengineering research. We also have Dr. Mohammed bin Omar Sanusi, who's an associate professor at the University of Southern Denmark, leading the Embedded AI Research Group. He has a lot of research expertise in AI, embedded systems, cyber physical systems, and smart autonomous vehicles. And finally, we have Dr. Amin Rabhi, who is the founder of Mena Make Technologies, which focuses on technical challenges in product development across the MENA region. He has a lot of experience in AI, quantum technology, embedded systems, and medical device R&D. So thank you for joining us, everybody. And I will now give the floor to our panelists. They can introduce themselves in any language they want, English, French, or Arabic. So yeah, thank you for being here. And Dr. Skender Zouari, if you're here, can you please give a brief introduction by yourself?
Yeah, thank you, Sofian. Thanks to all of you guys for organizing this very interesting meeting. So my name is Iskandar Zouagi. I'm Deputy Director of EMP, in charge of Information Communication Systems and External Relations. And I am an Associate Professor in Supply Chain Management and Information Systems in the Industrial Engineering Department at École Nationale Polytechnique. My research focuses more on supply chain management, information systems, whether dealing with transactional decisional systems, and some of the use of nowadays of artificial intelligence and generative AI. Thanks again. I give you the floor. Thank you.
Thank you very much, Dr. Zouari. And now we move to Professor Tawes Mariam Lalek. Are you here?
Yeah, I'm here. Thank you. Thank you very much. Hello, everyone. Thank you for the invitation. So very impressive event and impressive organization and also impressive talks. So thank you so much. So yeah, my name is Mariam Lalek. So I graduated from École Polytechnique in 2004 from automatic control. And I'm currently senior researcher at INRIA in Paris-Saclay, where I lead the BOOST team, or bioinformed monitoring and optimization for enhanced sports and health. So my background is in control and signal processing, but I work a lot on interdisciplinary research related to biomedical applications. And in the past, as you mentioned, so I was in KAUST for 11 years. And I actually also worked a lot on other applications related to water desalination, wastewater treatment plants, aquaculture as well. I will be happy to, to take part of this panel. Thank you.
Thank you, Professor Lalek. Dr. Ben Omer, are you here?
Yeah, Assalamu alaikum.
Yes, could you please introduce yourself? Alaykum salam.
Yeah, are you hearing me?
Yes.
Okay, good. Oh, Assalamu alaikum. Shukran على invitation. Thank you very much for this invitation. Thanks for the organization of this event. All this kind of event is very interesting for us and also for the students in Algeria. So master student, PhD student, I think they will learn a lot based on this kind of events. And doing events online makes things more easier for a lot of people. Yeah. Thank you for organizing this. My name is Mohamed Sanusi, and I'm associate professor in STU, Southern Denmark University. I graduated from l'IMPG, L'Institut National Polytechnique de Grenoble, and I prepared my master's there, my PhD, and my engineer's degrees from University of Sidi Bel Abbas. So I'm Algerian, like 100% Algerian. And after this, I traveled a lot. I worked in the Netherlands, the University of Twente. I worked in Paris. I was associate professor in l'École Centrale, and then I went to the US in North Dakota State University. I was a faculty member and associate professor there. I met a lot of Algerians there, so this is why they invite me. And then since 1 year and a half, I'm leading a research group of embedded AI in SDU, Southern Denmark University. And one more thing that people know me in Algeria through my platform Nukhab. So I have a YouTube channel, Nukhab, and Facebook. So I'm doing a lot of interviews for Algerians around the world. So this mainly what I'm doing, and I'm very happy to be with you and sharing my experience and taking part of this panel. Thank you very much.
Thank you very much, Dr. Ben Omer. And now move finally to Dr. Amin Rapi. Are you here?
Hello, you hear me?
Hi. Yes, we can hear you. Yeah. Yeah. Can you please introduce yourself? We can hear you. Hello, can you hear me?
Yeah, do you hear me now?
Yes.
Yes. We can hear you, but it seems like you cannot hear us.
And I can hear you, I think now. Hello?
Okay, great. Yeah, we can hear you as well.
Okay, great. Sorry for the delay. So
No worries.
thank you for the invitation, and it was great event. Seeing all this presentation about these different topics. So thank you. It must have been very difficult to organize. So I'm happy to contribute and uh, to this good discussion and to the event. So just a quick background. I am from electronics engineering, of course, in École Polytechnique of Algiers. I went to France. I did a PhD in biotech. So we were making a labo chip device to detect pathogens like viruses. So I was there for 4 years, and then I worked at the instrumentation company for microfluidic researchers. So basically, we made real sensors and instruments and software for laboratories around the world to do microfluidic research. So to do the same thing I was doing as a researcher. So I transitioned to the private sector, and then I came to the UAE 2 years ago, where I worked as a CTO of a medical device startup, and afterwards, since a few months back, going more into an entrepreneurial journey, where I am a consultant for the other technology startups. I help them get into the market here, and I assess for businesses technologies with other projects going on that is still in ideation stage. Thank you.
Thank you very much. Thank you very much, everybody. So yeah, now we're gonna move on to the questions. So how this will work? We're gonna have some questions in the screen display. Shakib is gonna take care of that, and the questions are gonna be directed. For example, a question for Professor Laleg, and then Professor Laleg is gonna answer. But like after she answers, we want everybody to kind of give their opinion about the same questions if they want to. So we will kind of have a discussion, especially between the panelists. If anybody from the audience has any question that you want to ask a question, just put it in the chat, and then we will ask it to the panelists. So the first question would be, based on your multiple disciplinary experience, what are the best practices for supervising PhD students and young researchers? So I guess this question is like general. So if anybody wants to start answering the question, if anybody has any idea and wants to start answering, please feel free to open your mic and go for it.
I can just give my opinion on this question, if you don't mind.
Yeah, of course.
So I think that there is a very important thing to do in supervising research works as PhD students or young researchers. So I'm speaking like as almost young researcher. So I think that first of all we must define like a clear goal at the beginning, because there is a first problem, which is sometimes the supervisor has a general idea about new research. So he doesn't have really a clear goal in defining a subject. If the goal is clear, it's okay. So the PhD work or process will be managed easily. So when the goal is not really clear at the beginning, so he must work, I think, in really close to the student or PhD students. So like having regular meetings and trying to define very quickly a clear goal and really very clear smart objectives, and then the the supervisor, I think he must define like the best skills of his PhD students to like find whatever are these skills to be, for example, maintained, or other skills to be developed. And then the supervisor, I think, must help the student to go through the research process, to learn how to go quickly through the research process if the student is not ready or not he doesn't used to go through this process. And then I think also another point which is important is networking. So the student must develop quickly a network around the PhD project, so that he can identify what are the most important teams, the most important universities, that the most important, the most known, or the most researchers, the most researchers that have the authority in this field, and then try to contact them, try to work on, try to do his like a literature review depending on this networking, and try to follow what they are doing, and also integrate some integrity and ethics in his research. Learn to do it, because it's not easy at the beginning. So just some ideas about my very small experience.
I may add actually something, if possible. Yeah, so from my experience actually with advising, of course, I agree, like with the research goals, even if it's not always easy actually to identify the clear direction for the PhD at the very beginning, and especially when we do research. But I think the most important for me is to really work on understanding our students first, because students are completely different. Okay, some of them will require more flexibility, others will require more, guidance. So it's very important to understand actually what is the best strategy actually with the student. And the second thing that is very important for me is when I advise a student for a PhD, for me is a collaboration. Of course, it's not okay, let's do the work, let's do that or that, but it's really, we should see it as a collaborative work where we define our objectives together, because this also helps actually the student learn how to identify the problems or the challenges of the problem itself. And I think this is very important. And of course, regular meetings, but only individual meetings, because of course, when you have a group of students, and it's very important to also run some group meetings where the student can also present in front of other students the progress, ask questions, and especially when you have a multidisciplinary group, then you may put together mathematicians with maybe an engineer and sometimes computer scientists. So, and in that case, so you see that the engineer will add more, ask more questions toward the application and the usefulness of the approach, while the mathematician will try to add more rigor to the questions that he asks. So, and this is actually very also productive in a multidisciplinary group. And I would add also something very important is reflecting on the work. Each time actually, this is also a recommendation for our PhD students, is to do like reports written reports, because reading and writing is part of the PhD project, of course, not writing papers only, but actually reflecting on what we are doing, like from time to time, like a weekly basis, or I mean, if you have time, of course, this will help you, of course, progress in a better way. So this kind of the recommendation I give to the student initially, but for me, the most important is really to identify which kind of student it is, whether flexible approach is useful or more, some, really clear directions to provide to the students.
Thank you very much, both. This was very insightful.
Okay.
Yeah.
May I?
Dr. Sirus, you want to add something?
Thank you. Yeah. Thank you very much. Thank you for Skandar and Miriam. So in the questions, I think that means something that when we speak about supervising PhD and research, we speak about successful supervising. This is the thing. So there is a lot of practices, that we can the supervisor do or prepare or with the PhD student or the researchers, but some of them sometimes are not successful, others are successful. When I speak about successful, speak about how the PhD research by the end will be successful to finish and to deliver a very good job or very good results. This is very important because by the end, which is very important for the PhD, the good results. These good results will open up a lot of doors behind in order to go for academia or go for industry, either when you have or when you did a good job during your PhD. That means a lot of things will be very easy and mainly for a job. This is what we want to do by the end. So a lot of practices based on my experiences. So in order to go for like successful PhD, so there is this link or relationship between the supervisor and the PhD. And in order to create a good link, so what I used to do, that I need to take my PhD student as a scholarship for 6 months or 5 months or before starting the PhD with him. So this, I have to know more about the candidates that I want to work with. And mainly, before sign for a PhD with him, he will stay in my group for at least 6 months, working on some subject, research subject, and then see what's the link between me, the others people from my team, and the new team that the new candidate or new PhD student that will join. This is very important because this makes easier how to go far, for the PhD. And then the second point, which is very important, is about my colleagues Skandar and Miriam already speak about it. It's about how to define the subject or the research subject. This is very important. And mainly what I did, since what I'm usually doing, is to try to create or to define this subject with the student, not just me. And in order to do it, I give him like 6 months and maybe 1 year almost. The first year is dedicated just to define what we want to do, and mainly based on the experience of the student and what he wants to do exactly. Of course, we post the position. What you will find, or what we put in the position, advertising the position, we put just keywords, okay? And once we have a good candidate, or I have a good candidate, so when we start working, so I give him like a real good time in order to define. And this definition, or this subject definition, make sure that we will go ahead till the end of the 3 years or 4 years of work. And this is one of the things that a lot of people has to take it in consideration, that not the professor or the supervisor will define the subject alone. This is not very good idea. Just for sometimes is clear when you have industrial PhD, les tests chiffres, كما يقولوا في فرنسا. That's more easier for people. That's subject is coming from industry. Industry has like a real problem, and we want to solve the problem. Okay, and for me, it's not really a research; it's more engineering than research. When you are doing a SIF, civil or industrial PhD. So when I speak in general research, so this is the second, the second point that's very important in order to go for good result by the end of the PhD. So the third point I want to speak about is my colleagues already mentioned is about the meetings. Meetings. What I'm doing also, so meeting every 1 week, 2 weeks, presentations, progress presentation every 1 month, something like that, and then what we add also a reports every 2-3 months. There is a small report about the progressing. Mainly this reports not just for me as supervisor, but helps a lot the PhD student in order to write papers. Mainly all these reports, after 6 months you have 2-3 reports. You can turn it on papers for a conference or journals very easier. So we have already a lot of discussion about the reports, about what side of the reports and what you wrote. And in order to write a paper, it will be very easier for the PhD. So this mainly, this mainly the what you call it or what we call it practice or good practice in order to make the PhD successful. Thank you.
All right, thank you so much, all of you. Now, moving on to the next question. Okay, Shakib, the next question, please.
Sorry, I have just a question related to this question. I just write it in the message if you can read it.
Yeah, so we have a question to Dr. Snoussi. Dihya is saying, I agree with you, but unfortunately in some countries and for certain funding, it is not possible to do this because annual reports must be submitted on the progress of tasks or groups of tasks. Could presenting 6-month research internships before the start of the PhD be a good option?
I don't know if I did understand very well questions, but yeah, when I speak about 6-month internship, mainly I would take it for stage. You know, before I select my PhD student, I'm trying or do my best in order to have him as intern for a couple of months in order to build this link and make sure that he is able and he want to go for a PhD for 3 years or 4 years. Because mainly this is one of the biggest problems that we have. We need to make sure that the guy or the lady that we will take it as a PhD candidate has finished or will finish his work. And work for 3 years or 4 years is long and not easy. And so the first step for 6 months work, try to have like data and information about the candidate. Okay, and at the same time also working on some technical stuff, research stuff in order to have an idea about the level of the student. Okay, it's if he is good in doing research, doing implementation and this stuff. And what is the other? What is the questions? Unfortunately, in some countries, it is not possible to do this because I'm a report. Yeah, but other countries, you know, in order to take enter for internship, student for internship, I think it's open for everybody. There's a lot of master's students and engineers students. They are looking for a PFE, projet de fin d'études. So you can find this a lot all around the world, even in Algeria. There is, and based on this PFE or this last year project, you can have an idea before starting the PhD. So this is what I mean when I speak about the 6-month internship. Or yeah, you are very welcome here. You're very welcome. How about I answer the question?
I mean, just to add, actually, the internship is very important for sure. And it's not only to define whether the student is good, but also to see whether there is a compatibility between the relationship between the student and the advisor, because the student might be very, very good, but unfortunately, I mean, we have different style of work, and so it might not actually be a good
yeah. Yes, William, this is very true, and this is what I have several students that I am working with in Algeria. I think there is Algerian PhD students in here, and this was there is a lot of people. They have like one email or one meeting with the supervisor every 1 year or every 1 year and a half. It is just crazy, you know. Yes, this is mainly coming from all this stuff. So the supervisor define the subject, the student apply for the subject. He said, yeah, you will take here, but they have no idea about the supervisor, and the supervisor had no idea about the candidate, and this is make things very difficult in order. And I get a lot of feedbacks from a lot of, as I said, a lot of students, PhD students call me on Nukhab in order just to have a discussion about this. And mainly this is one of the big problems or big errors or big issues that's coming back every time. And to be honest, right?
Yeah.
I had a discussion with the ministry, Kamal Badari, just about this. I said it's just not normal that the supervisors can't speak with his PhD for 6 months or for 7 months or 1 year. Okay, so I think they are working on a platform in order to make this visible for everybody. That means the university can follow what's happening between the supervisor and the PhD. So this is what they want to do. I don't know where is if they started already
I think that's very important indeed.
Yeah. This is very important. I said, to be honest, so supervisor in Algeria, they get money. This is what he told me, the minister. Monsieur Kamal, this is what he told me. They're getting money in order to supervise, but they somehow not doing their work. But there is this misunderstanding, or let's say, like this gap between the supervisor and the student in order to do, like, finish the job. Sorry that I'm taking more time. Go ahead.
No, thank you. Your answer was really, really informative. Okay, let's move to the next question. How do the research cultures of the countries you have experienced differ in terms of funding, infrastructure, and collaboration opportunities? And I think this question is mainly for you, Dr. Sanusi, and Dr. Mariam, as you have experienced research in different countries.
I can talk about my experience, so between France and KAUST. So Saudi Arabia, I would say, but unfortunately, it's really about KAUST, not Saudi Arabia, because KAUST is quite a unique. I think it's a unique university, like in terms of model, actually in Middle East. So what I would want to say, so we are talking about funding. So the main difference here is that in KAUST, we have actually a baseline fund, so which means that the faculty will get a certain amount for 1 year, every year actually, to get maybe 1, 2, or maybe 3 PhD students and 1 postdoc, which is really, really, really great. So which means that you can do your work with only this funding. You don't need to go and search for extra funding. But of course, I mean, it's recommended as well to get more if you want to do extra work. I think this continue because there is a big change now in KAUST, but I think this baseline fund continue. And at the same time, we have competitive funding like in other countries. Initially, it was within KAUST. So which means that KAUST we propose a competitive funding to the faculty in order mainly to promote interdisciplinary research and to try to make faculty from different divisions work together. But since last year, because now they changed the system, so they have a new vision. And so now they actually created the kind of the funding agency for Saudi Arabia, which is kind of NSF or INR for Saudi Arabia. We call it RDAI. And now they actually include all universities, like for this call of funding. So they are kind of, changing the whole system. So it is more becoming like actually the other countries now. So there is less competition within KAUST, but now KAUST is competing against other universities. Even, I mean, they have, I would say, more chances to get funding, but they try to also regulate this, you know, how to give the funding so equally like to all the universities. In France, of course, it's different. It depends where you are first. I'm in Paris-Saclay, and Paris-Saclay is a very, I mean, is a dynamical environment in the sense that there's a lot of opportunities for international students mainly. So there's a lot of actually PhD funding that target international students. But if you want to look into more France in general, so of course you have to apply. Most of labs here in universities, they don't have like actually this baseline fund that I was mentioning in KAUST. So basically you may have like funding just, you know, to attend one conference or two, or maybe to get at INRIA at least to get like a master's student, but for PhD you have to try to get your own funding, so you have to apply for extra funding. So there is the French agency, funding agency, INR, or European, at the European level as well. We have a lot of opportunities, so you have to go and get this, you know, and try submit the reply to these calls for funding and try to get extra funding. Collaboration opportunities, of course, in Saudi Arabia, the ecosystem is different. Especially in KAUST, it was quite isolated. However, it was very dynamic in the sense that they really have a strong collaboration with mainly US universities and maybe UK as well. So even it was quite isolated. So we see that there was kind of, you know, desire to bring the word to KAUST, if you want. But of course, even if there was a big effort, it was not enough in my perspective. I mean, the university was small, so I was maybe the only one for several years working in control. So it means that we are quite isolated at the end. So you don't have this, you know, this kind of environment that would push you like and make you like collaborate with people in the field. And of course, in France, it's different. I mean, just 3 years in Paris-Saclay, we initiated so many collaborations because the environment is here. So, yeah.
Thank you so much. Dr. Snoussi, if you want to add anything.
Okay. Yeah, it's very important question, this one, because once you speak about funding, or we cannot speak about research without funding. The funding is very important in order to do research, and mainly when you want to do like what we call free research. When you are freedom, we have a lot of freedom in order to do what you want to do. Exactly, there is no target subject by the government or by any other people that will give you money. This is very important. And when we speak about countries, it's really different. It's really different. Maybe I will speak about different experiences that I had in France. In France, is like there is as Miriam said, it's INR, Agence de Scientifique de Recherche, or something like that. That's give you money in order to work in any subject. And how it works mainly, there is two types of funding, like funding coming from government and funding coming from industry. What we call it CIFR, because Ayoub, I think, the last presenter was on Thèse CIFR. That means the money is coming from industry or coming from the governments, and the governments through the INR. And in order to get some money, you have to apply. There is deadline for course all the years, different course, and this course they have a deadline. You prepare your applications. 2 universities, 3 universities alone. So there is a lot of possibility in order to do this. Depend on how big the fund is or how big the project is, and then there is this possibility in France. Mainly these two things. In INR, so you are more. There is a lot of freedom in order to work on the subject that you want to work on. Exploring things. INR is very good funding, or very good opportunities, give you good opportunities in order to go through what you want to do. Then there is industrial PhDs, what we call it CIFR, the test CIFR, and this more the subject is decided or is mainly defined by the industry. So we are working on collaboration. The thing that I don't like it with CIFR is very hard to publish. You know, it's not something that's created for publication. Mainly people working. The PhD will work for 3 years in order to find an industrial solution or like a technical solution for industrial problem, mainly. By the end, like deliver software or deliver any solution for the problems that the industry. There is a lot of industrial people or industrial companies in France doing this. This is in France. So when we speak about, I had experience also in Netherlands. In Netherlands, is more money is coming from the Netherlands. Money coming from the also from the research department in the States, and mainly what they are doing, they give you a money, but you have to involve industry inside. That means you have to work on a problem. That's problems, or you solve some problems, and the solution has to be dedicated or at least prototyped within the industry and with industrial partners. They are pushing in order to put industrial partners. In Denmark, it's the same thing. In Denmark, it's the same thing. They have a lot of money for research. There is a lot of course every year, and one of the things that also pushing like industrial research. You have to check and find problems for. It's very hard in order to get money in order to do fundamental research. For example, you know, all the research they are pushing for is practical research. Okay, this is one. In the US, it's dependent on the university where you are. The people they are in the US. In the US, there is like universities oriented or research oriented. Other universities is teaching oriented. It's depends what university you are, and the same thing. A lot of money coming from industrial or for particular, let's say. Yeah, but we can't compare what's happened in the US in terms of research with by what's happening in the Europe. Even the Europe, they have put a lot of program like H 2020 or Horizon 2027. This kind of course that push European countries to work together. And they give very good money, but in order to get your consortium, and it's like a lot of work, really a lot of work. It's not that easy to do it. Yes, but they can't compete with the US. They have a lot of money in the research, and mainly if you are in university-oriented research, yeah, there is a lot of funding. I give you an example. A friend of mine who was in the university in the US, he wrote a proposal in half of a day, and he gets $500,000. He has an idea. The deadline was like for tomorrow, and start working on it today. And the funding goes from HP, Hewlett Packard, so the company, the IT companies. And this is what happened to the US. When I was there, also I get an email from 2 guys that was working. They did their masters in our university. They run their startups, works very well for them. They come back with $1 million in order to help university in research. And but they came with their original subject. They want to work on like a very specific subject that they was looking for supervisors for that, like professors that they work with them. And yeah. It's different from one country to another, and I can say something about South Korea. I was working there also, and yeah, it's a bit the same. Now, the mainly Western countries, they are pushing in what's it called, country-to-country collaboration, and they get some money from Korea. When I was in France, I did this call or this application between South Korea and France, and we get also money in order to do research. And a lot of students, a lot of researchers are doing this. trying the government and pushing people or researchers in order to connect with other countries, and the funding will be like split it between the two countries, and let's make things more easier. Yeah. So mainly this is what I want to share with you guys. Thank you.
Awesome. Thank you so much. Let me just take this quick question of Amin. He's saying, is there a plan of CIFR equivalent in Saudi Arabia for research and industry subjects?
Actually, there is no CIFR PhD, I would say, like what we know in France, but there are actually a PhD sponsored by industrial companies. Let's say Aramco, for instance, can sponsor a PhD in CAUS. So the student will get actually a PhD from CAUS. So it's not like there's not this kind of distinction that it's a CIFR PhD. And most of the time, the topic is not really, provided by Aramco. It might be done in collaboration, but it's not something like as strict as, maybe what we know here in France when you have a CIFR subject. But there is this relationship like industry, university, yeah. And there was, I think, a previous question about what drove me out of CAUS. So, of course, there are some health personal issues, and at the same time, I got the opportunity of creating the project team at INRIA, like the Boost team, which was also a great opportunity for me.
Okay, thank you so much. Now, moving on to the next question. How does a PhD...
if I can add just one...
Sorry? Yes, go ahead.
Yeah.
Of course, yes.
So I think that the previous question is very important because the research culture depends not only on countries, but can depend on the field of research, can depend on the, for example, on the TRL level, the technology readiness level. So when we are doing research in the TRL 1, 2, or 3, so we can look for fundings from countries, from institutions like European Union or very big structures. And if we are in TRL, for example, 5, 6, and 7, we can look for some fundings from industry. So I think that this combination and the strategy of looking for fundings is very important. And also, if I can add another thing, is that autonomy is very important. We can have fundings, but we can not be able to spend our money. So it's very important to have fundings. For example, even in Algeria, I had an experience in France. We have been working with the US, with, for example, Switzerland, and so on. And sometimes autonomy is very important, because when we have money in research, we can spend it as we see it like opportune. But if we cannot spend our funds on our research, it's very difficult sometimes to shape the research depending on objectives. So we must be clear at the beginning, and then we have to look for fundings depending on the evolution of our research work.
Thank you so much for this addition. Now the next question: how does a PhD graduate perceive the value of this experience in an industrial context? Amin Rabhim, maybe you want to answer this question from your experience?
Yes. So for this question specifically, there is a similar question: is that how you can use your PhD experience to bring value to industrial context. Like when you're doing your PhD, you know that even if you do fundamental research, there will be in the long time frame value in the industry and in the economy. But in some use cases, like in my specific use case, we had a use case in the start of the PhD, which was to make a diagnostic device that was more efficient, faster to use, and portable. So we know that there is an economic impact in the biotech industry. But even if you feel that your subject is far away, keep in mind that these subjects, they all have they all have like an objective to either save time, make it more efficient in terms of energy, make it less more environmental friendly, and any of these goals gets back eventually to the industry. So you can value anything you do in your research to the industry, but some topics, as Professor Sunusi said, are more closely related to the industry and use cases, and more closely related to engineering. So it's much easier for you to prove your value to the industrial sector. So, so this is one use case. The second case where you can use your experience is that you use your deep technological experience to work in similar domains, or even in domains you don't know about, because you have the ability to understand complex topics in other industries. So I have seen this a lot. There's even PhD students who go to work in the finance sector because they have the ability to understand mathematics. So even if you don't think about it, there's a lot of value that you gain from your research work. So it can be in the same topic, it can be in adjacent fields or industries. You can use also the third one, which is the obvious one. You can use what you did during your scientific research work for startups afterward, or to build your own deep tech startup for the industry. In this case, of course, you need to have the patent, but you can also use, I know some people who use their AI expertise to build AI models for the advertising and marketing sectors, and for the sectors. So this is one of the few ways where you can value your industrial your experience during PhD for the industrial sector.
May I say hello?
Yes, of
Yeah,
course.
yeah.
You can go for
Yeah,
it.
okay. Okay, yeah, I want just to add something that's yeah, it's very important question. It's a good question also about people that want to do like academic research or industrial research. Mainly in the US, for example, you can value your PhD by your salary. You know, this is very important when when you are doing a PhD experience, or you have experience industrial PhD. You can negotiate well or better your salary in the industry, because someone is coming from 100%. In general, in the US, the PhD, when you have a degree or PhD degree, so you have like high salary in industry than the others. You know, this is how it's works. And with industry PhD, it's more better, or it's more easier. Something else also is depend what you want to do behind your industrial PhD or CIF in France. And the good thing sometimes, which is when you are in a new era or a new topic, and you will be the first working on this topic in this company. So by the end, you will be the leader of the group. You can create your group inside and continue working on this new idea. That means that you will be like more. You have more freedom in order to do things in the industry in comparison with any other engineers that is or PhD that is hired in order to do this stuff, this task or this task or this task. You know, this mainly also kind of a positive point regarding the industrial PhD.
Yes, just I added to this. In France, it's different. Unfortunately, when I switched from PhD to the private sector, it's difficult to value your PhD in terms of monetary value, in terms of salaries. But when you go to like more like British or American settings or environment like it's right. You can value your PhD and get a much better salary. So don't forget that you can leverage your PhD. You just need to be confident about what you did, about all the aspects, the multidisciplinary aspect, the soft skills you learned during your PhD, and to use that effectively to get your industrial job.
Just something else for the people they're doing the PhD is very easier to get the job later. So many a lot of people they're doing just in order to stay with the company and work for the company as an engineer or as a researcher. It's very easier. So they will know you there. They know what you are doing and what you did, and So we have already also 3 years, 4 years of experiences. So many of these people they want to do. They want to work for a company. They start with a PhD and stay with the company. Also, it's also easier way to get a job. Go ahead.
Thank you very much, everybody. Can we move to the next question, please, Shakib? Yes. Yeah. So this question is mostly directed to Dr. Zouari, but of course everybody can answer. Are there funding opportunities available to support research at EMP? If so, how can they be accessed? I mean, this question can be answered about EMP, but about Algeria in general, I guess. Yeah.
Yes, this is a very important question. There is a lot of funding opportunities, not really for PhDs, but for projects. So like PRFU, like PNR, we have like small projects, PRFU, which can help researchers to go through some research projects, but we have bigger projects like PNR, Projets Nationaux de Recherche, that can help researchers to have very interesting funds to go through their projects. How we can access it? We just have to contact. These are state fundings. Contact DGRSDT. It depends on the team. We can consult la TRST, which is a substructure of DGRSDT. And for example, we can see what are the major axes of research funded by the government, and then we can access easily these funds. But sometimes we have to prepare an industrial collaboration before. If we have an industrial partner with us, it will be easier, and sometimes it's compulsory to have it. And sometimes it's an option. We can have 1, 2, or more industrial partners, and even now. So we have to promote the creation, for example, of patents, so that these research can be valued through the industry, through this the licensing, for example, of these patents, and sometimes we can also have fundings through international collaboration. For example, we have collaborations. We are some proposals in Algerian, Italian collaboration projects. We have other collaboration projects, for example, with other countries, with Russia, for example, and we are trying to define the teams, the project, the labs, and After this, we can think about think about hiring PhD students in labs. So the texts depending on hiring PhD students differ depending on the objectives, depending on the policy of the government. And now, for example, we can hire PhD students depending on projects. So we must have a project so we can hire PhD students. But they are changing these texts, these policies, and to find ways to not to be constrained by projects, and to go from, for example, from a project to another one. These are some ideas.
Thank you very much, Dr. Zouari. That was very insightful. And you talked about Italy, and there's actually a question from Lakhtar Hamidatu that's asking, sorry. Yeah, all right. He's asking, is it possible to transform an academic PhD into an industrial PhD in Italy or other European countries? And he's also asking, in which year can this transition be made? And he's saying that he's enrolled in an academic PhD program, and he's asking if he can switch to an industrial PhD after gaining the interest of an industrial partner. If any of you would like to answer, please open your mic and go for it.
Yeah, maybe I would say just two or three things about it. We have to know that the PhD is related to the funding. Okay, each PhD is related to funding. It's dependent. Funding is coming from where. Mainly the PhD related to two things: the funding and the l'école doctorale. You know, the industrial partner will never give you the degree of PhD. So the degree of PhD is related to the university, the PhD school. You know, so the academic or the university is a very important partner in here. You can't make a PhD without a university, because in all the countries all around the world, even in Algeria, the unique institution that can give you a PhD degree is a university. Mainly, I speak about PhD students. Okay, there is others that can give you like honorific PhD, something like that. Is something else. But I'm speaking about teaching and doing research in order to get your PhD. This is the first thing. So the university is very important partners in here. The second thing is about the funding. Each PhD is related to the funding. If the funding is coming from university, so it will be academic. Your PhD, it will be academic in collaboration. Maybe could be in collaboration with industrial. It depends on the subject. Mainly, we will take industrial in order to do prototyping, to let's say try or validate or verify our solutions within industrial problems or industrial companies. But moving from one to another is depending on the funding. Okay, sometimes you can start as academia, and after 1 year, 1.5 years, you partner. So the partner, industrial partner, give you the possibility that your PhD student goes to the industrial partner for two times a week or 2 days a week or something like that. But as I said, it's depending on the funding. If the funding, mainly also it's half-half. Is half of the funding coming from academia, and half of the funding coming from industrial. And here you can switch between both of them. So this is mainly, but in order to have your degree, so you need to be a part of a PhD school. In a university, PhD school is very important. And this is what I want to say mainly. I don't want to go take more time about that.
For me, I mean, I want just to add something. Basically, I'm not sure what actually industrial PhD mean, because as my colleague just mentioned, so we talk about a PhD because it's related to university. So, but if industrial PhD means that the work is done involves somehow a kind of industrial partner with maybe some impact in industry, like something related to kind of an application, I mean, maybe away from a very fundamental topic, then I believe that this is possible if you identify actually your industrial partner. So I don't see why we cannot actually, I mean, the topic can be updated like during a PhD journey. I mean, I remember my own PhD, so I started by modeling the arterial blood pressure. I ended by doing some semi-classical signal analysis, so based on the Schrödinger operator, which has nothing to do with the beginning of the PhD. So of course, the PhD adapts to the opportunities that comes to you. It's a long journey. And yeah, everything, I mean, I don't know what industrial PhD mean, to be honest. So I think that's what we need to define first.
Thank you very much. Yes.
I think that industrial PhD, from my point of view, is a PhD which is financed by the industry. It can be not really, I don't know if we can call it like this, but generally it's a problem of switching funds. So if we can switch funds, generally we can go from, for example, like academic PhD to industrial one, because we have the applied part, which has been developed very quickly. But I think in the other way, it's more difficult or more used in the research processes. But I think it's open. It depends on switching on contracts, on the industrial contractual articles and so on.
I want just to add something from my understanding. So when we speak about industrial PhD, there's two things to speak about it. The first thing, that the funding is coming from industry, and the subject also is coming from industry. And as Miriam said, so the subject can be moved from academic to from like I'm academic professor or academic department that they propose the subject or industry, but mainly funding is coming from there, and also the subject coming from the industry. Sometimes the funding is coming from the industry and the subject coming from academia. That means industrial, they trust a very good professor and they give him money in order to work on this subject, okay, and the subject is defined by the professor. That means it's defined by the department and defined by the academia. So it's when you speak about mainly industrial PhD is about money, about the funding. It's coming from where? So that means the industrial is funding this research projects.
Okay, I will just read these comments before moving on to the next question. Selim is saying you might be referring to PhD engine, if I'm reading it right, which is industrial PhD in Netherlands. It's a 2 years period versus the normal 4-year period, and the tasks are vastly different. So this might answer the question of what is an industrial PhD.
Yeah, that's true. In Netherlands, when you have a PhD, so you can find people that they are PhD and their name, and there's other people PhD ENG and their name. That means they passed by the industry, and as I said, this collaboration between academia and industry in Netherlands is very, very highly, let's say, developed, very strong and very developed, because sometimes you are leading the research, or we are leading like engineering team in Thales or any other ASLM or ASML or any other big company from Netherlands, and you are professor in the university. So I had this guy with me as a professor. He was like one day working with us 1 day a week working with as a university as professor. He is professor. At the same time, he is leading a team of EMC at Thales at the time. That means there is this easier way to move or to switch between industry and academia. And I think this is the only in Denmark also, but in another way. Denmark, you can go for the industry for 1 year, 2 years, and come back But in Netherlands, no, you are professor, and at the same time you are working for company. This possible though.
That's great. This really gives insights to people who would like to pursue a PhD, which has an industrial application. So they would consider maybe the Netherlands or Denmark.
Exactly.
Yeah. All right. The next question.
I have a question if you.
Yes, sure.
Yeah.
Go ahead, Abdelhai.
Related with the funding process.
Absolutely.
Just guys, Mr. Sunusi, maybe you have a relationship with the ministry, and so that's a good thing. I have a question is, can you share your idea and your thought how to make the funding system and in general the system in Algeria more efficient and more reliable? The government can support many research, but there are many wrong people just take the money and go. And I think if the funding system is go to the right way, there are many Algerians can go back to Algeria and make more collaboration, etc. So do you have any idea, guys, how to make the funding system in Algeria? Especially there isn't a strong relationship between the industry and the research. It's totally different than here in US or in Europe, guys. So can you share your thought how to make the funding system process in Algeria in general more efficient, more trusted? How to make the government trust the people and make the money, provide everything? The same thing what happened in US and in Europe. If you make funding, they just make a quick review, something recommendation, then they give you all what you need. If you, especially, guys, maybe you have a good relationship with the ministry. We need as an Algerian, I hope if the system that can be more strong and more Algerian, I'm sure more Algerian than we'll make collaborations and go back to Algeria to do research, etc. Yeah.
It's an important question. It's a hard question at the same time. I think the simple, as I said, if you have, in the beginning, we had this discussion about the relationship between supervisors and the students or PhD student, or at least, let's say, a PhD student will take him as a researcher and the supervisor also as a researcher. And this relationship are not that good, in my opinion, in order to make this trust between the supervisor and the PhD student. And I think this is the first step in order to do it. Why? Because the supervisor will somehow approve the money that will go for his student in order to go for an internship or something like that. And this is like a low level that we can speak about. Okay, and if we speak about in general, the lack that we have in Algeria, that there is no traceability. We give money for the researchers. I know that I had just 3 weeks ago, I had a visiting professor, a visiting PhD student from Algeria that I'm working with him for a couple of weeks in here. So people or the country or the government give money for the researchers, but there is no, let's say, follow-up. Okay, they go for they go for their internship. They go for what we call it the end PhD end period, something like that, for scholarship for 8 months or 9 months or 10 months. They give money, but there is no follow-up from the government, and this is what we speak a lot about it. That means the student or the researcher from an Algerian university get money. At least if we take the example of internship, يجوا هنايا يجوا لفرنسا ولا يجوا mainly يجوا لفرنسا ولا يجوا ليوروب mainly in order to spend some to do research. This is what they have to do. But we are not following them. There is no system, there is no platform that following this researcher, Algerian researcher, in order to see where they went and what they did. Okay, and it's something that became like automatic things. Well, you have internship once a year. They give you, I don't know how many dollars. You take dollars. You come to France. You can. Dernièrement, 2024, la plupart تاع les خلينا نهضروا الجزائريه. La plupart تاع les هذول اللي عطاهم دي بورس وكاع راحوا للترك. روحوا للترك وروحوا لتونس، خاطر الفيزا تاع فرنسا كانت واعره، الفيزا تاع جلوبالمون الفيزا تاع لوروب فاني كانت واعره. بزاف منهم اللي يروحوا لتركي وروحوا لتونيزي. ايش راحوا يديروا؟ وي دونت نو. يقول لك بلي تلاقيت مع بروف ارسل لي انفيتاسيون تو ايا مشيت وصيد. بصح شي دار تما اسكو البروف اللي روح عنده غادي يعاونه في التست تاعه، اسكو البروف كي يروح لا تركي اسكو هذا البروف اللي يروح عنده اسكو يعاونه في لا ريشيرش تاعه ولا. and this is one of the big problems. This is really big issues. وهذه ما جايش غير من الجوفرنمون. كي نهضروا حنا رانا بيناتنا الجزائريين وكاع ما جايش غير من الجوفرنمون، هذه جايه من التربيه، جايه من التعليم، جايه من lot of things. اوكي، جايه من ترست. اذا كان انت الدوله تعطيك $1000 ولا $2000 in order to do research. اذا رايح تروح لاوروبا ولا راك رايح لاوروبا بدير ريسيرش ولا راك روحوا لتونس قعدوا 15 يوم.
I'm totally, Dr. Sunusi, sorry, I'm totally against. It's not from the government 100%. It's from the people. I'm
بن علي I'm not pointing out this ولا هذا ولا. There is a lot of things around. One, if we speak about a large view or a global view, we need a system that follow every researcher, like a platform. We had a discussion about it. We had a really discussion about it with the government. But a platform, online, people, they want to go in 2024, people they will do research in 2025. And then, of course, as everywhere, we need, I give you money in order to do a PhD. So by the end of the PhD, we need feedback. We need output. We have the output like everywhere. We speak about software output or hardware output. Est-ce que درت prototype ولا ما درتش prototype؟ البوبليكاسيون اللي بوبليتهم، واش جورنالز اللي بوبليت فيهم، هذا كاع follow up. And I think we missed, or the government missed this part of the work. They راهم يعاونوا يجيبوا money وكاع. There is a part of government has to do, and many parts from researchers. And also they have to take this in consideration. The mainly for me, the problem is the following up. Okay, خصنا حاجه وين كاين تراسابيليتي ونجموا نشوفوا الريسيرشر اكس شرا يدير والريسيرشر بي، وهذه جايه من الجوفرمنت ولا من قبل الجوفرمنت is department itself. Okay, this is my point of view.
Yeah, excellent, thank you. I just wanted to raise, and I think it's the time to discuss seriously this thing. There are a lot of Algerian, mashallah, everywhere, and we need something serious in Algeria to make a strong relationship between the industry and the research, and make some Algerian do real work in their country. That's exactly the point.
Yeah, you had pointed something very important. What is very important that we can make, there is at least like really no relation between the academia and industry في الجزائر. And
Yes.
هذه we need to work on it. And if you want to work on it, حضرنا على الام بي هنا الام بي ليكول تاع البوليتيك، نهضروا على ليكول تاع الاي ان، نهضروا على ليزي. هذول big schools where we have very good students. They can set up something. بصح they're trying. I know that they are trying to do things. بصح we can work on it in order to make it more stronger. في الطريقه هذه ما يكونش نتكلوا دائما على الجوفرمون باه يعطينا الفاندينغ تاع البي اتش ديز ولا تاع لي ستاج ولا. So we can get also funding from industry. وكيقول لك هذا الشيء مش نحكي لك على صناعه التراك وصناعه الغاز وكاع even people they have like companies they are very good successful companies في الجزائر they have money نحكوا باش سيبا نحكوا على لي جون تاع لي تي في لي تيلي اسمه هذاك كوندور نحكوا على كوندور نحكوا there is a lot of big successful people they make money and they want to invest بصح still there is no like a platform that makes sure that the two worlds can be connected.
Yeah, like an organized framework.
Exactly. Yep. Yeah. And it takes time. It takes time. It's not easy even in France. In France, they're trying to do it, and it's very hard for them. Also, currently, Sophia, currently the country. You have Scandinavian countries that are doing this very well, and you have US. You have US. They have like very strong link between industry and academia. بزاف جوجل من يخرج من الجامعات.
Absolutely. Thank you.
Thank you.
We cannot hear you, Sofian. Your mic again. Okay. Yeah, all right. Okay, so this is going to be the last question we have here. So how can alumni contribute to the continued growth and development of the institutions? So déjà had la question, and you can answer it in whatever language you want. To alumni, que ce soit ta Polytech ou ta whatever university. Ou je pense que had la question déjà is a good follow-up على the last discussion that we were talking about. Anyone who would like to contribute and answer this question on how we alumni can contribute to that. Anyone can take the lead.
I don't understand the questions. Do you mean like the school or the students or
yes, like we, the students, the alumni, how can we contribute to the continued growth and development of the of Polytech or Algeria in general, or how can we contribute to the research, make it better?
Yeah. Want to start? This is okay, guys. Yeah, I can start. Yeah. So this is Ashwaq. This is one. So this is one of the like very important questions. When we speak alumni we take it as a network. Okay, and networking is very important. هنايا كيحكوا على alumni تاع البوليتيك ولا we speak about Algerian network, right? Okay, and without network we can't do anything. At least we can't do big things. Okay, and this is very important that في الجزائر we are very weak in this. We are Algerians. We can't work together. Everyone can work alone. He can be successful alone. But when it comes to networking and do something big together, is very hard. Alumni, for me, is a starting point in order to have this strong network, in order to work together. Okay, if we take the Algerian main the Algerian culture, let's say, as I said, we are not doing well, even outside, even the people they are outside. I have a lot of experience in this, and I did Nukhab just for this, in order just to like put all Algerians people together in same things. Sometimes we are successful, sometimes no. So me and a friend of mine, we did this, what we call it AI board, Algerian AI board, the Conseil National de l'Intelligence Artificielle. Okay, and we worked together for one year and a half in order to do the national strategy. Okay, and national strategy of artificial intelligence launched just last Saturday. September, we were in Algiers in order to launch this. It was a part of the African Startup Conference in Algiers. Okay, and this alumni for me is part of this networking in order to do like good network or strong network. This is the first point. The second point, when you are alumni, you don't have to forget from where you are coming. That means كما يقول لك إذا تعاود ترسل l'ascenseur. It's very important. فاهم? You get position there or there. Even in Algeria, I'm not speaking just about the people they are outside of Algeria. Even in Algeria, you became professor in here ولا head department تاع sales ولا head department of engineering somewhere in the company. So you need to come back to your school and take some students from there, تفورميهم تعلمهم, and this is very important. As I said at the beginning, I want to come back to it. Making a strong network is starting from alumni, or at least alumni is a part of doing a very good network, you know. And when you are in network, احنا كما يقولوا في الغرب يقول لك اليد وحده ما تصفق. اوكي، اليد وحده ما تصفق. باغ كونطخ كي نكونوا 6 و7 و10 و100 you can do big things. So I think alumni, behind the alumni build very good or very strong network is very important. And in order to do this, one of the main important and the crucial thing that learn to work together. Okay, learn to work together. That means I'm not alone on earth. And Jazairi, we are, as I said, we are bad in doing this. Because, as I said, there are a lot of people outside, even a lot of people, smart people everywhere, Jazairi, but it's very hard to do like strong things for Algeria or even for ourselves. Okay, and this the alumni is like starting point in order to work on this. This is how I'm looking into it. Thank you.
Thank you, Mariam. Maybe you wanted to say something.
Just say that, of course, that les alumni, c'est les ambassadeurs en fait de l'institution, tout simplement. So where I think every big university is kind of giving a big importance to the alumni section, and because of this, you know, so alumni are first they have to give back to this institution in different ways. So networking, as like we just mentioned, of course, that's a very important point, as we are doing right now, right? So sharing ideas and thoughts, experiences, and also, seeing kind of these big universities. So alumni give also sometimes even funding, money, job opportunities. Okay, so alumni will go back to the institution in order to hire actually those kind of students graduating from the institution, because they know what are actually what is the institution, what kind of courses they did, what kind of training and they had. So I think there are so many ways of how alumni can contribute to the institution, and I believe that as Mr. just mentioned, so we cannot, in Algeria maybe we are not doing actually enough. That's why I said it several times that what you're doing here, guys, is very important, and but at the same time we should do more and more in order to help the institution. So for me, it's very, very important to go back, and I'm as a researcher, for instance, I got the position actually as a permanent position. I always come back to UNP for getting actually some, doing some collaborative work, giving some ideas for topics for students there, like BFE, master, etc. But what I want to say is that it needs to be also a two-way process, because the institution is also to accept this, to value the alumni as well, because when we see the institution closing the doors to these collaborative work, is also maybe not helping or not maybe facilitating, the work of the alumni, in contributing to the institution. So it has to be also like in a two-way. Not only alumni has to do something, but also the institution has to value also the alumni. I think it's a two-way process.
Yes, absolutely. Yeah, right. Emin, yeah, you wanted to say something?
Yes, just quickly. Just to terminate on a positive note, I know a lot of alumni who contribute to this day to the community of the actual students, PhD students. I know some professors who each year try to bring students to do PhDs in UK, in here in the UAE, in France. So at an individual point of view, that each one they try their best to contribute to the community. In terms of professional work, it's the same. When you try to reach out to anyone, and I suggest you do because people are afraid to ask, to reach out to the people in the industries or in the consulting companies. Like 90% of the time, people will respond to you and they will help you. So don't be afraid. You need to ask. Go ask for the other one. And then for the collaborative effort, it's much more complicated because then the incentives in this case needs to be aligned between each party, and that's where it always doesn't work because I've known like 5, 6 big big initiatives, but they almost don't work because incentives between each party are not aligned, and it ends up in like in the stalemate. It's like the project gets paused or it goes very slowly. This is unfortunate, but I think we'll if we continue to be consistent, we'll find a way to make it work, inshallah. And that's it from my side. To get back to the industrial point of view, I think that as we have people from each industry, like we have people from the consulting part, we have people from the government, we have people in the alumni, from the industrial sectors. I think there is a way to make big projects, to make deep tech projects, deep tech companies, deep tech startups, and to make it work and to have a financial incentives. But still to this day, didn't find a way to make it click. So this is like just my opinion.
Monsieur
If I
Zoueri,
can
yeah,
add
maybe you
just,
want to share your perspective about that.
Yes, just one thing. It can be like even short actions, but frequent. So, and sometimes the problem is that I think that alumni and our colleagues also need to just involve colleagues from our institution, for example, from EMP. It's not easy, I know. It depends on the colleagues, it depends on the students. So involvement is very important in big or small projects. But I think that even organizing this by the alumni can be also interesting, because sometimes the alumni wants to share something, experience, his involvement in projects, his ideas, his scientific approach, or his experience in some technologies. But we know that all of us don't have really time to share. So sometimes like an initiative, like frequent and very short initiative, like 20 minutes or 30 minutes each week with the students, even in extra academic curriculum, can be very interesting with some objectives, and then involve them in some projects can be very valuable. And also, for example, involve the colleagues. So I work a lot with my colleagues in some lot of countries, but sometimes these colleagues, so we involve them, for example, in some projects in Algeria, but some of them have has some very interesting projects. So, for example, when I was in France, I had a lot of very interesting projects. So when we involve a colleague from Algeria in a very valuable project in Europe or the US or elsewhere, it can be very interesting for the colleague or professor, and also for the students, because they can have like some very small projects. They can help them. They can orient them, and it can be very valuable. Students need also to see what are real or concrete projects existing in like ecosystems, other ecosystems, because in Algeria, you talked about the relationship between the university and the industry. So we don't have really very good tradition in this area. But in other countries, we have this kind of links existing between industry and the university. So students need to see concrete things. So here, we don't have a lot of projects in this kind of fields, but I think alumni and colleagues can contribute really in this area. And we have an example here, and also with the other student clubs and initiatives, we have a lot of sharing of experience, sharing of like the use of some technologies, the use of some methods in industry, because a lot of alumni has very big experience in some fields, and we are open. So I think, for example, in École Nationale Polytechnique, I don't think that students, when sharing with them some interesting things, they can stay with you a couple of hours, and they can work hard to learn some technologies or some concepts or approaches. And I think we have to find a way to keep the alumni like given ideas or organizing things by himself, and sometimes we as colleagues are here to help. For example, tomorrow we'll have a very big expert in IEEE. He will come to École Nationale Polytechnique presenting. He's working in the Air Force lab in the US, and he's in Algeria. He will present, do a conference for students, for colleagues. This kind of initiatives are very, very important, I think, to first to share experience, and then to create this link, and to discuss, and just to develop this link between alumni. Thank you.
Thank you so much all for your contributions. I will yield the floor to Shakib for some conclusion notes.
Yeah, I mean, thank you very much actually for this very nice event. I really enjoyed listening to all the presentations and also answering the questions, so which are very, very important questions, of course, and not always easy to answer. Yeah, but of course, I think I mentioned it like during my podcast. I think what is very important for me is mentoring. I think that research mentoring is something that goes together. Networking, I mean, it's part also of networking, but mentoring in particular. So I believe that maybe having more mentoring activities would be something very interesting to do.
Yeah, thank you very much. I really appreciate it to be part of this panel, and thank you for the invitation, and thanks Ashwaq, thanks about me and invite me for this event. Yeah, I'm open also in order to do kind of works and collaborations with the school, which is very important. This is what I shared just with the scandals. I have some opening for a PhD. And I really looking for some students, and I really want to take some Algerians from there in order to work on some subjects around embedded systems and embedded AI. Yeah, this what I mainly I want to share with you, and I will be more than happy to give a talk in the school. And then I'm invited for several. When I'm in Algeria, I'm invited for several talks in different universities, and of course, Polytech. I wasn't there, but yeah, I will be more than happy in order to share what I'm doing in my research group with the student, and of course, as Miriam said, it's very important things about monitoring and helping and supervising, co-supervising people, and even for inviting people to come in here to learn. I would be more than happy in order to help. Yeah, we can do it. You can do it like this, and also I prefer to be face to face with the student. It's more. I'm coming to usually. I'm coming to Algeria next week. To be honest with you, yeah, I'm coming to Algeria like several time a year. But yeah, of course, I'm open for both suggestions.
Yes, just two things. The first thing, thank you very much for the event organization and for hosting this important event. Um, the second thing is to keep things concrete. I remember we had a database for the PACINP.com about the alumni profiles. I don't know if it is still up to date, but for other researchers who are attending this event, they can use that as a way to get into collaboration, to find people who work in the same field of them in research, and to set up a collaboration between the two universities, whether it is UNP or whatever they are doing their PhD. Second thing, when it comes to entrepreneurship or tech startups, or if you want to assess your technology idea and have questions about getting into industry, you can always reach out to me. I'm available on LinkedIn. Just send me a message and there's no problem. I'll do what I can to help. And if I can't, I can try to connect you to people in the same field you're looking for. And thank you again.
Yes. So first of all, I just want to thank all of you, thank all of the panelists, all the presenters, and thank you, Shakib, and thank Ashwaq, and all of the organizing team for this very, very interesting initiatives. So I just encourage this kind of initiatives, and we are here to help, to share, and we are open in Connaught Polytechnic. I'm speaking as like associate professor, and I'm speaking also as the deputy director. I am in charge of external relations, so we are open to collaborate. We can go very quickly if our colleagues are open to collaborate. So we can just go very quickly. We can help. It's not always easy, but we can just fix if there is any problems, any constraints. We can go through thinking about some solutions, even for fundings, for projects, for internships, and for PhDs. If you don't hesitate to ask. You can have my email. You can just have my LinkedIn profile, or you can just send me through the Shakib, or I am open to help and also to learn with you. So thank you again, and bonne continuation.
Extra? يعطيكم الصحة.
يعطيكم الصحة.
السلام عليكم.
شكرا.
Thank you all.
السلام عليكم.
السلام عليكم.
السلام عليكم.